all our honored guests who have joined us today at the International Agbiol Congress. Your presence here is truly appreciated, and it highlights the importance of what we are about to discuss. Now I'm inviting the Trakya University Orchestra to the stage. In the spirit of recognizing this honor, it's my pleasure to invite our esteemed President Professor Yalçınkaya to join us on stage. Having the President here emphasizes how significant this event is, and we are excited to hear their thoughts and ideas. So please join me in giving a warm welcome to Professor Yalçınkaya as we eagerly look forward to their speech, which will guide and inspire us throughout this event.
Dear Vice Rector, dear colleagues, Dobro utro, günaydın, bonjour. Thank you for coming. Thank you joining us. We are proud of that is organizing indoor Agriculture, Biological, and Life Science Congress, 5th one. Even in the pandemic, we didn't stop. When we organize online everything, we are so happy that this year the record participation we got is the almost 833 papers. Over 2,000 authors contributed. So we are so happy that to organizing this 5th one. I hope we can continue the same because we have you see that our university facility, we have very nice city because it's Edirne, it is was capital of before Istanbul in the Ottoman Empire, 92 years. So it is a very historical place. We are so very nice, the Congress Center and everything. So in this case, I mean, we have to so happy that see you here. I wish to too many participants, of course, but all because our conference is a hybrid. Almost, we have 250 participants in the coming year, and then in the almost more than 300 also online participants. So in this case, we are so happy that because, the world is expensive day by day, everything is because of the inflation. We respect that their decision. I hope all together, of course. But anyhow, it is, we are happy that, to see again here. So I would like to just say a couple of brief information. And there is a all session. There was another Congress hall, seminar hall. You will see it in the right side. There's a trio of them is the upper. In this case, also there is some rooms also will be organizing online. So also there was it is the live from the YouTube. So everybody in the world can watch us. And then all the participants, the online participant could see. Also, there is a poster hall. So we put every 1 minute, there are the poster in there. So you can see all the poster if somebody want to see and to you, because some of them already picture, you can recognize who is the owner. Anyhow, also, I mean, the internet also we are publishing in the e-poster as well. So in this case, we will not do special poster session, but there was Microsoft Teams, and then you can reach in the Microsoft Teams. There is a poster discussion. If somebody asks about some question, some poster, you can write down, and then poster owner answer you. So sorry about that. We didn't put in the transport, the city, because different hotel, we don't know for this. But in the evening, it could be, if you are late, we can supply some transport to city. But anyhow, we don't know exactly who is stay until there, or it doesn't matter. And the lunch will be at 12 o'clock, 12 and 1 o'clock. We will give you the Balkan cuisine, different test, also a local test, and then in the lunch will be free there, and in the Wednesday night we have the gala dinner at the end of the conference. It will be organized. Of course, we will give that in the. There is a location, and barcode, in QR code, it will be available, the place. So you can ask about, in the or gala dinner, it will be in the special dancing party, everything, including meal and something. And then, of course, if you join, it will be, but please write your name, who will join or not. So because we know this place, how many person they will join there. So it's the, I don't want to talk more, and I would like to thank again our sponsor, because we have the many sponsors supporting us. So in this case, we would like to thank our sponsor to organize this event, nice event. And also I would like to thank our university, give us the opportunity for this. And then also my organizing team, they perform tremendous job. So my students, we are all together, almost 50 of them, many of them we performed until today. I hope you enjoy our event, and I would like to thank again coming to Edirne. Thanks you to see you again. We wish we continue to this event in the regularly every year. That is our plan. I would like to see you again in the next years too. Thank you for participation.
Now I'm inviting Biljana Vasileva to being a chair here.
Okay. Yeah. Good morning to everyone. I am happy to be together this morning with you and to open our opening session. We have 3 presentations from our speakers from neighboring countries, Turkey as host country, Greece and Bulgaria. And every speaker has approximately half hour to present the results. After each speech, the speech will be open for questions. So, in this case, let's give the floor to our first speaker. It is Emeritus Professor Dr. Apostolos Kyristakis from the International Hellenic University, Greece, and the topic of his speech is olive oil as a functional food. I apologize for not correct pronunciation of the names, and you have the floor, please. Dr. Kyristakis.
Okay. Here.
I think yes.
Can I talk from here?
To you.
It's up to me, okay? Huh? Okay, good morning to everybody. First of all, I would like to thank the chairman of this important conference, Professor Yatsin Kaya, for inviting me for this important conference. I come from Greece, as you see. I come from the island of Creta, where, you know, it is the area where we have the most production of olive oil in Greece, where I finished my my high school and then in Aristotle University at Furthermore. Well, I would like to thank also Turkan Keseli from Adana University who introduced me to Professor Pia. And I'm here with my fellow Kalabos Anusakis, who is, his name appears here. I'm really impressed with the initiation of this Congress. I had the chance to travel around the world to participate in many conferences at the Congress as an invited speaker, and I see something different, which is really good. You started with music in order to bring us in a good mood, actually, which is really good. So, as it was mentioned, I'm going to talk about olive oil as functional food. First of all, you have to know that the olive oil, there is a great talk about olive oil nowadays internationally, due to its important composition, due to the fact that it plays a very important role in our health. And due to the fact that this has the biochemistry department and other departments at biology and so on, it may be interesting the things which will be pointed out in this presentation. As you see, the names is Keseli, Turkan, and Anusakis. Keseli comes from Adana University, and Anusakis, my friend, comes from a big cooperative union. He's a very good scientist in the area we shall talk about. Oil was referred to as green, as a liquid gold by Homer, and as a good healer by the father of medicine, Hippocrates. Hippocrates was born, as you may know, in the island of Kos. Olive oil composition, it contains actually the saponified fraction, which are mainly triglycerols of oleic acid, and unsaponified compounds, which are very important for our health. Biological roles both in plants and in humans. Here we have a better picture for the compounds which are really important for our health. You see the unsaponified fraction of olive oil participates to a small percentage, 1.5 to 3%. But this small amount plays a very important role for our health. Here we can see polyphenols, alcohols, tocopherols, and in a study which we did comparing biological and conventional olive oil, we found all these compounds in both oils. Nowadays, there is a great talk about biological production of olive oil in Turkey, and in Greece, and in other countries too. And you probably know that in Turkey, we have an increase in the production of olive oil. The recent years, they are called biofunctional compounds, these constituents which are existed in the olive oil, like the phenolic acids, flavonoids. Oleuropein is the most predominant phenolic compound in olive drab. It gives the bitter taste, but it is really good for our health. So if we consume olives which are, have a bitter taste, it means that they are good for our health. Oleuropein, it is a product hydrolysis of oleuropein. The hydroxyrosol is a very important antioxidant compound which can be found in olive oil. Also, it's existing. We can buy it from the market, as you know. And now we can see in the next picture the different classes of olive compounds and to see the importance of this. You see phenols, tocopherols, sterols, and carotenoids modulate the reductive oxidation procedure activities. The flavor compounds and also the chlorophyll and phytin facilitate the absorption of antioxidants from our body. So it is really important to consume virgin olive oil, which may have good taste and aroma, because this constituent facilitate the absorption of antioxidants existing in the olive oil and also in the food. So it should be interesting to take into consideration this point, that if we have an olive oil with a good flavor, it contains, of course, antioxidants, it will be good for our health. Here we have some beneficial and healthy effects of olive oil constituents. They play a very important role, as I mentioned before. Also here we have the minor compounds, but we shall stay in this photo, in this slide. The presence of these compounds, the phenolic compounds, there is a great talk nowadays about phenols in olive oil, which not only in olive oil, in other products as well, in other food as well. But let's see the factors which affect the presence of phenolic compounds and of aroma compounds in virgin olive oil. First of all, it is the cultivar. Cultivar play a very important role. The maturity stage of the fruit, the harvesting time and the methods, the environmental conditions, the microclimate where the olive tree is cultivated, the extraction process, the process which is applied to get olive oil from the olive fruit, and also the storage conditions of olive oil. So the phenolic content of olive oil is a genetic characteristic of it. It's very important parameter. If we go back in the 1980s, you will see some data which are related to an experimental orchard when we thought that it may be interesting to see how the phenolic compounds present in the olive fruit may be eliminated or may be reduced with the process of fruit maturation. So we ran an experiment using the cultivar Tsunati, which is a characteristic cultivar in an area of the island of Creta, as I mentioned, the place where I come from. At that time, I was working in the Institute of Subtropical Plants, olive oil at the subtropical plants before I moved to the States. And we see that with the time of maturation, we have a decrease in the presence of phenolic compounds. So if we harvest fruits early and we process, we shall expect to have more phenolic compounds. So it is important to see which are the phenolic compounds. In this study, because those days we didn't talk about phenolics, in 1980, we talk only about acidity, about composition of olive oil, about sterols and other, but no great talk about the phenolic compounds. But nowadays, there is a great concern about this. Now, we see that the group of olive oil polyphenols, which are flavones, pyrosols, phenolic acids, lignans, and so on, these appear in the food, in the book Olives and Olive Oil as Functional Food by Zahidi and myself, a book which was published by Wiley some years ago. And I had the chance to include, the honor to include in this book authors from Turkey and from other countries, from Europe, from Africa, from United States, and from Australia. It was a great honor for me For this particular book, there were professors from Adana and also from Istanbul, from University of Istanbul. Here we have the phenolic compounds on olive oil again. There is a characterization, a categorization of these products, phenolic acid, and so on. I don't want to stay more in this slide, but I would like to spend a few minutes on this slide. You see, we have here the process. There are the process how we can obtain olive oil. And if we stay in this point where we say it contains high level of polyphenols, it is an extra virgin olive oil. If we go here in pomace olive oil, which is the oil which is obtained from the pomace after we get the oil initially, it is applied actually a chemical process, a refining process, the amount is low. And also here in refined olive oil, which undergoes the refining process, the amount of phenolic compounds is low. So we start from extra virgin olive oil, we go down. It is eliminated as the process goes down. But we can have even higher amount of phenolic compounds in some categories of olive oil. As we shall see in the next slide, please. Now here we have, I don't know if, no. Here we have actually the construction of decanters, which is the main part to obtain olive oil. We have two-phase, a three-phase decanter. If we have someone here who is working on this area, he has to know that the two-phase decanter gives higher amount of polyphenols, because we are considering about the amount of polyphenols which we shall have, than the three-phase decanter, because in this case we add water to obtain the olive oil, while in this case we don't add water. And we have also other methods and techniques where we can take more amount of phenolic compounds. We have the microwave energy. There is a great talk, a great research nowadays in Italy, even in Turkey, in Greece, and in other places. We have also the pulse electric field. We have high power ultrasound and so on. So the point is that the technology, the science, try to see how we can eliminate the losses of phenolics which are existing in the olive fruit initially, and how we can get more during the olive processing to apply the new techniques during the crushing of the olive fruit or during the malaxation step in order to have this amount of phenolics which are really important for our health, for our life. Also, what we did here, we try this by Kyritzakis K, the results, he's my son. He tried actually to increase the presence of phenolic compounds by reducing the waste waters which are coming out during the processing. And we see actually some increase in the total phenolics, and also in the individual phenolics, oleocanthal, oleacin, and so on, by reducing 50% of wastewater. There was not big difference between 50% and 100, but there was difference between the control and 50%. No difference between 50% and 100% of wastewater, but there was difference between the control of this. So, in the radical scavenging activity, we notice actually, again, the same thing, difference between the control and 50% olive meal wastewater, but not big difference between 50 and 100%. Here we have some data related to the effect of the pulse electric field for 3 cultivars, data from Italy, where we have actually the Carolea cultivar, very known, Odobradica, Ecorantina. We have in all the cases increase in the total phenols. We had also increased oleuropein, compare this, this. In oleuropein, we had also in lignoside, in lignans, and so on. So this technique, which applied during the processing to obtain olive oil, gets up with higher amount of this product, of this constituent. All we are familiar with EFSA. EFSA is a European Food Safety Authority, which has a specific rule, a specific law, let's say, for olive oil polyphenols. Acceptance say that olive oil polyphenols protect the lipid from oxidative stress, and they have to have this oil in order to claim as very good for our health, must have 5 milligrams of hydroxytyrosol as its derivatives in 20 grams of olive oil. And of course, this comes up with a European Union Law 432/2012, EFSA, European Food Safety Authority. This is a very important point for the olive oil, because Europe, they realize the importance of this product for our health. Of course, if we shall see in the next slide, we can get more than 250 milligram per kilo, 250 ppm. This guy, Sakelaropoulos, who is a friend of mine, I had a chance to meet him 35 years ago in Thessaloniki. He is working in biological, is the production biological olive oil, and he is the first in the world in producing olive oil, table olives with high amount of phenolic compounds. You see here, it's called Aristoleo, this oil. It has, here is the number of phenolics, here is the number of phenolics. So we have higher amount than 250 ppm, which the EFSA realized as the limit amount of it. The products of his production, I mean, are used in Yale University, in Harvard University for studies for our health. It is really important, this. Here we have the table olives, Kalamata olives, which are really known in most of you. We have here 303 milligram ppm, in other words, 800 higher, and we have here the tyrosol and hydroxytyrosol. So we can increase the presence of these compounds in our product by applying the proper treatments. Now, the antioxidants, the phenolics, in other words, may quench the singlet oxygen. I had the chance to do my PhD, part of my PhD, for singlet oxygen, and we see that in olive oil, constituents like phenol and chlorophyll promotes oxidation due to the fact that we have the formation of singlet oxygen, which is very drastic compared to the common oxygen which we breathe. But there are some other constituents, like carotene in our case, which cause coenzyme of the formation of singlet oxygen, which works 50 times faster than the oxygen which we breathe. So the antioxidant, in our case, the carotene, cause quenching of singlet oxygen. Here we have some other chelaton of iron, copper. If we have iron in oil, this antioxidant may cause chelating, as you know. So there are several effects important effects of this product. Here we have the relationship between total polyphenols and the oxidative stability. You see the line. Here we have some other data to see how we have the extraction of these compounds if we have increase in the temperature. And we come now to oleuropein. As I mentioned to you before, oleuropein is one of the most important constituents in olives. And it has very, very significant effects for our health. They have anti-inflammatory, reductive oxidation system modulation of this, anti-infection, and so on. Again, we see the importance of the polyphenols in olive oil, health effects, anti-inflammatory, and so on. And we shall stay more about oleocanthal. Till the year 2005, there was no talking about oleocanthal, which is really important constituent on olive oil. Like I mentioned to you before, till years back, we didn't talk about polyphenols in this in the olive oil. And I say here that oleocanthal is one of the most important phenolic compounds in extra virgin olive oil. It has anti-inflammatory activities, and we point out here that similarity in structure between the ibuprofen, which we take from the pharmacy, and the oleocanthal, the similarity structure, explain the anti-inflammatory action of oleocanthal present in olive oil. So it is really important to find out this compound when we analyze the phenolic compounds in olive oil. And here we have oxidant and antioxidant balance aging hypothesis, a slide which was given to me by my friend Frangel from the University of Davis. When we are young, there is a balance between oxidant and antioxidant defense. As we go up and we become older, like I am, we need more antioxidant effect in our diet in order to be healthy. Here we have some information related to oxidative stress. I have the honor to be the chairman of Observatory of Oxidative Stress in Greece, which was created by an Italian guy, very important fellow. And we talk now about oxidative stress and oxidative distress. If the reactive oxidation species present in our body and the antioxidant, if they are in balance, we end up with the oxidative stress. Good stress. Stress means good stress. While if there is imbalance, there is not balance between those in our body, we end up with oxidative distress. Our body and our gut microbiota share the so-called reductive oxidation system according to our friend Eugenio Iorio. Again, the reductive system is one of the most ancient and efficient adaptive systems, comes in different areas, in plants, in elements, and so on. Yet we go there to this slide to see that if we have oxidative distress, there is not imbalance between active oxidant species and the presence of antioxidants. Then we have different diseases which appear like Alzheimer, stroke, atherosclerosis, but they don't have specific clinical picture. We may end with cancer, early aging, and so on. So it is really important to see the telomere. Telomere is a Greek word, which is telos means end, and meros means part. So DNA protein structure, this is the telomeres. They appear at the end of chromosomes. And as we become older, telomeres are found at the end of its DNA, as I mentioned. Over the time, the telomeres are sorted. The length is sorted. Once the telomeres are too short, DNA cannot make correct copies, and that particular cell stops developing. Shorter telomeres are associated with several age-related diseases. As the telomeres are shorter, we have the appearance of several diseases. And we see now that, again, the factors affecting the telomeres, factors influence telomere length, and so on. And here, in this slide, we have the modulation of reductive oxidation system. If we have factors here we have factors, which is the Mediterranean diet, the Cretan diet, sleep duration, and others, which avoid the shortening of telomeres. This is a good factor. Here we have factors which accelerate the shortening of telomeres. Bad factors. Then we end up here with shorter of telomeres and ending with several diseases I mentioned to you before. How we can obtain, how can we increase the length of telomeres? There is the enzyme telomerase, which increases the length of telomeres. Okay, how the telomerase will be activated? Two phenolic compounds, as we mentioned here, oleacin and oleuropein, work positively, increase the length of telomeres. Similar effect has the hydroxytyrosol. So these constituents present in good quality olive oil, we have to take into consideration the factor. We have to prefer virgin olive oil, extra virgin olive oil, which is the best for our health. So all this cause increasing of the telomeres, and they may have a good effect for our health. Again, similar effects from this slide, health heating. Here we have bad effect. We stay in polyphenols. Generally now we talk about polyphenols in olive oil. You see, they increase the insulin sensitivity, while they decrease the oxidative stress. They increase the mitochondrial biogenesis, while they decrease the oxidative distress, and so on. So several effects of these compounds which are existing in good quality olive oil. Here we have the pathological aging, controlling oxidative distress, I mentioned here, and inflammation are the right factors for a successful aging. On the left side, we have the pathological aging, while in the right side, we have the health aging. Pathological aging. Here we have the inflammation zone. While here, when we have the health aging, we have effect of the telomerase, which increase the length of telomeres. All these kinds of things end up with good effect for our health. So it is really important to take into consideration this factor, how we shall increase with the proper food, with the proper ways, the length of telomeres in order to end up with a good effects for our health. Conclusions. olive oil, I mentioned, is a fundamental food, very important for our health. It contains biological constituents which are really important. Addition of wastewater during the olive processing meal, olive processing to obtain olive oil, we may increase the presence of the phenolic compounds for our health. Also, some new techniques I mentioned to you before, like pulse electric field and so on, may increase the presence of the phenolic compounds in olive oil which comes out from the centrifugal mill. The unique characteristics of intestinal microbiota, as I mentioned, may influence the phenolic compounds availability. And generally, polyphenols play a very important role in oxidative distress because we want to have the stress, not the distress, in the length of telomeres in order to increase the health, in order to eliminate the aging. And here are some of the books which contain this information. There are some in Greek, some in English. There is also one in Spanish. I had the chance to be in Chile and Argentina when they used this book. Once we try with some Turkish student who came in my university to translate this book, Olive Oil, from the tree to the table, but finally she went to Europe, so we didn't finish it up, but we may translate it if it is useful for Turkish friends. And I have the honor to have friends from this country. We are neighbors, we are good friends, and we have to cooperate, and we have to be in contact, we have to exchange ideas, we have to exchange research data, because we cannot stay nowadays eliminated. This is the point I would like to mention to the young fellows, and I'm glad to see young fellows here, which is really important. Years ago, we thought that if we find something important, it is better to keep it for ourselves. But now it is too wrong. You cannot stay it for yourself. You are not the key of the world. You see that as you go in, you realize how, probably you know the Socrates, what he was saying, how short you are as you go on. So it is good to have good cooperation with good friends from Turkey and also from other countries to end up with good results. Here is the picture of the new book on olive oil as biochemical and the role of olive oil in our life. This was presented some days, I would say, last month in my town, in Crete, and I was really pleased. And here we have the book, Bailey's Industrial Oil and Fat Products, published by a great professor, Feridun Zahedi. He was born in Iran, but now he is in Canada. He is a great professor. He did some congress in Turkey, in Antalya, and in Istanbul. And we have a very important chapter in this book. And by the way, when I first went to the States, I bought this book. It was the 3rd edition those days, but now we are talking about the 6th edition. It's a great book. It's very important for the people who are working with the area, in the area of fats and oils. Here is another paper which was published in the journal edited by Feridun Zahedi. It came out some years ago, recently, and now we have another one which is in press, which is published published by a great professor. He was in Antalya last year, and he invited us and some other Turkish professors to write a chapter. He's a doctor, but he pointed out, he understood the importance of olive oil for our health in the medicine. Hippocrates was talking about the role of olive oil in our medicine, and all these old great people. So we have to take in consideration, and I'm really glad, I think, again, the organizing committee, especially the Professor Pia, for giving me the chance to be with you to talk about olive oil, which is really important for our health, and we have to take into consideration the several factors which may increase the value of this product. It's not only to say, I consume olive oil, but what quantity of olive oil we consume. Is that virgin olive oil? Is that, of course, it has some consideration the cost of the oil. But if we have the chance, if we can do that, to buy good quality olive oil, we should try that. There is nowadays, as at the beginning of my presentation mentioned, there is a great talk. There are panels in different places. I have a friend from the island of Mykonos who was the other day in Istanbul evaluating olive oils, samples, another also from Tunisia doing the same. So it is really important to take into consideration that there is a great talk nowadays about this product, which is really important for Greece, for Mediterranean areas. It is important for Turkey too. And you had increase in the production of olive oil recently here. And by this, I would like to thank you very much for your attention. And again, I'm really glad I had a chance to be with you in this beautiful audience, young fellows, young places, very nice team. Thank you very much.
We are thank you also to you, Professor Kyritakis. And now the speech is open for questions. If you have, our assistant will help. Please. The presentation was very interesting. Thank you, really. If you have.
I will go there now. I will go there. Okay.
Is there any question? Or opinion, of course. Maybe everything was clear. So, no questions? No, in this case, once again, thank you, Professor Kyritakis. It was very interesting. It was related with one product which all of us, or maybe most of us, are using in our life. Is related to our health also, with agriculture very strongly correlated to the topic of our conference. Thank you very much.
Thank you very much.
So, thanks. And now we are going to our second presentation. Sorry. It belongs to Professor Dr. Ender Makinesi from the Istanbul University, Cerefaza, Turkey. And the topic is ecological processes on the conversion of coppices to high forests in Turkey, Thrace. Once again, apologize for not correct pronunciation of the name. Now you have the floor.
Thank you, Chairman. Dear colleagues and guests, firstly, I would like to thank to Professor Dr. Yalçınkaya for inviting me to this event, and it's very honor to be in this hall because my hometown is Edirne, and I I grown up Edirne. I rise in Edirne, but I'm in Istanbul University more than 30 years. And I would like to say welcome to all guests. I hope you can make good memories during conference time with the Turkish hospitality. My presentation is about some ecological conditions, properties of Turkey, and mostly about forestry and forests. I prepared the subject and the presentation about the European part of Turkey. And also I worked at the beginning of my Master of Science study up to professorship and intensively European part of Turkey, and another name is Thracian part of Turkey. We conduct many research and my profession is about the ecology and the soil, and I prepared this presentation with my colleague, and he was an old planner, forest management planner, and he is now in Research Institute in Istanbul. And he was dealing also with social forestry and management, forest management. And after introduction of the ecological conditions and the forests of Turkey, I will try to present the COPIS management. It's very important management style in management of Turkish forests, and it was abandoned in 2006, and the most effective management for not only whole country and but also the local conditions of European part of Turkey, and there is serious effects. There are many serious effects for public and management of forests. As you know, Turkey is a bridge country between European and Asia continents. And it is a peninsula surrounded by the seas. And if we talk about the big life zones in the world, biomes, Turkey in the temperate zone, upper sizes polars, cold climates, and the lower sides subtropics. And we have the mainland Mediterranean and the temperate climate characteristics. And Turkey is a mountainous country, and the mean elevation is more than 1,100 meters, and the highest place, our mountain, is the 5,000 meters. Depending on the geographical characteristics, mainly depends on the mountain seas located to parallel the coastal seaside, sea line. And this geographical characteristics creates a more humid climate on the coastal sides with the orographic precipitations, and the inner sides of European part of Turkey and the Anatolia Peninsula has very arid conditions. And these geographical conditions creates different rainfall and climate properties. And as you see on slide, rainfall precipitation changed 200 millimeters and 2,000 millimeters at the East Black Sea region. As you see the isographic curves of the precipitation. There are many different precipitation values depending on the area. And also temperature change depending on these conditions. In extra, in the eperogenesis and the orogenesis occurrences, more than 200 million years ago, our Anatolian Peninsula was a big hole. And the pressure of two plaques, continental plaques, with the press of stack of two plaques, causes to rising of the Anatolian Peninsula. And the peninsula was the hole, big hole, and then big mountains occurs. And we see the sea fossils even in the high altitudes in the places in inner parts and the high altitudes mountainous lands of Turkey because of these occurrences at the eperogenesis and the orogenesis movement occurrences. And these movements, characteristics, and geological events create many heterogenetic differences in the geological materials also. And depending on the different climate characteristics, soil weathering processes, and depending on the different chemical and physical characteristics of the parent materials, which are the soils derived on, and you see the very heterogenetic parent materials, geologic materials, creates very different soils, soil properties in Turkey land. And you see the major soil groups in Turkey. As I mentioned, many different climatic characteristics, soil, geology, and the geological occurrences creates a big biodiversity, rich, diverse ecosystems in Turkey. These are classified, grouped under 7 main ecoregions, depending on the main ecological characteristics, as you see. And these heterogenetic ecological conditions create many different ecosystems. And this also caused to reach flora species and the fauna species in Turkey. And diversity is very rich in our country. As you see the numbers, more than 10,000 vascular plants. It is called as the richest countries in the world in case of the diversity, biodiversity. And we have more than 4,500 rare species and more endemic species in Turkey. Also, same situation for fauna and the faunistic species. As you see, the 122 mammals and 454 species of birds and 130 reptiles. Maybe the numbers can be increased after introduction of new species by declared of scientists or us. And our country land use portions classified like this. Forests occupy quarter part of Turkey. And depending on the humidity and demands of the forest trees, forest areas distributed the coastal sides of Turkey, especially Mediterranean and the Black Sea regions. And deep valleys in the Asian and especially Mediterranean region caused the forest distribution with the humid air goes up to inner parts of the peninsula. And we also have the very rich tree species. The first one is oak, Quercus. Turkey is a Quercus land. And we have many functional plannings classified by the forestry functions. And these are also called recently as ecological services of forests. Forests serve us with many services. As you see on slide, wood production, nature conservation, hydrology, hydrological regime, erosion control, and many ecological services served by the forest. Some pictures from our forests to refreshment and the good views. We have good forests in Turkey, mainly on the Mediterranean and the Black Sea regions. And all forests in Turkey belongs to government. A few portion, a small portion of forests, less than 1%, belongs to private owners. And all public law, forestry law, and the regulations are made by government in Turkey. And the planning and the regulations of forests and the forestry management characterized by the three forest types, and these are protection forests, no wood production, and as they are the protection forest, stays without cutting or any forest management, and the national parks may be forested areas, and these are to use recreational and touristic aims, purposes, and the third one is production forests, mainly classified and separated for the wood production. And the main characteristic of Turkish forestry, Turkish forests have forest villagers. And forest villagers live in forests or edge lands of the forests, have special rights. This population decrease year by year because of migration to cities and the decreasing on rural populations, and now current portion of this population is about 9% of Turkish population. They get all incomes from forestry activities, and the government has to give many promotions, subventions, and supports to forest villagers like this. All promotions and supports are given by the Regional Directorate of Forestry. And the forest villagers, as I mentioned before, forest villagers has special rights. And the wood production of Turkey is about 32 million cubic meters, and it is not enough for wood process industry in Turkey. And I guess Turkey import same amount wood every year for wood process industry. And also we have many secondary wood products, and national parks, and seedling production, plantations, main activities of Turkish forestry. And the main threatening factors of Turkish forest fires. Yesterday, 3 forest fighters dead in a helicopter accident in Izmir, and the last week, 1 colleague dead in Kütahya against fighting against the forest fires. And we manage forests as 2 types, is a coppice management and the high forest management. This is very important for all country, and especially for the European part of Turkey. Coppice management means the sprout originated forests and the vegetative parts of forest trees give new sprouts after cutting, and at the beginning we guess the forester thought that disadvantages, because all the root system promote the new roots, and the big root systems feed the less sprouts. And they planted the forest with the clear cuts every 20 years. And what you produce in the coppice management, just thin woods, sticks, and you see the using purposes of this production woods. And the high forest is seed-originated forests and nature-based forests, high forests, and no clear cuttings, and it has the selective cuttings, as you see right corner on slide, and the coppice management causes to losing of plant cover at the rotation periods, and the high forest not lose the plant cover, tree cover always on soil, and it has always protective effect on soil. Coppice management in 2006 years was abandoned in Turkey, and more than half of Turkish forests planned to conversion of coppice to high forests, and as you understand, this is a big disaster for forest villagers getting income from cutting and forestry activities, because cutting amount of wood sharply decreased after this decision. And it has many big social problems. And the reason of the decision of depending on the many ecological nature factors, because the old stems of the coppice originated forests are not healthy anymore. As you see the lesions on the stems, and they cannot give the new healthy sprouts. And depending on the climate change, other disease, also many biological agents are effective on the coppice originated declines on the coppice originated forests. Fungi mostly is Phytophthora, and insects, disease, and also root declines, root deaths, old coppice originated trees like this, and you see the root rather sections, you see the leaf roots and the dead roots on and other many stress factors are effective the declines of the coppice or old coppice originated trees and forests. There are many stress factors there were. And what we did after declaration of the abandon of the coppice management, we conduct many research projects, especially on the European part of Turkey. And this part of Turkey has the coppice originated forests and the intense coppice management. All forests in European part of Turkey are deciduous, no conifer forests in this part. And you see from the highest point of the Strange Mountains in the inner fields of the Thrace, European part of Turkey, and the Yıldız Mountains, Strange Mountains goes. We sampled the forest depending on the age, young, middle age, and the old age. And we conduct many research about searching on the health conditions and the biomass and the wildlife species, insects, you see the pitfall traps, and depending on the many characteristics to research. Also, we evaluated the defoliation rates of the trees in sample plots, biomass sampling, how much biomass in the area, unit area, how much stem, foliage, branch, and bark in unit area. We determine these properties, and also we publish in many publications them. I don't want to bore you with numerical results, and we follow the effects of the decision conversion of coppice to high forests, how much changed biomass, what about the carbon budget in ecosystem, and how the biodiversity, faunistic properties change, also bird species, other big mammals. And my colleague also conducted another side of the research. What happened, the declaration of the conversion of coppice decision, what are the social effects for forest villagers, and he concluded that after declaration of the conversion of coppice decision, more than 60% of the forest villagers not happy, they are unhappy. And they believe that the conditions, life conditions, getting worse. And the employment hiring portion of the forestry workers in forest villagers decrease. Also, income budget decrease deeply, sharply after declaration of this decision, and they are not satisfied with this decision. Thank you for your patience. I think I used the time puncture.
Thank you, dear colleague. And now, if you have any questions, again, I'm inviting you for question, for opinion also, to the speech and to our speaker. Again, everything is clear. Okay, thank you, dear colleagues. So now, sorry, I didn't saw. There is one question, and our assistant will help. Sorry.
Thank you very much. Thank you for a very interesting presentation, really. I'm not dendrologist. I have never studied, but I have some information. And in your presentation, you showed about the Strangia mountain forest.
Yeah.
Yes, and the Quercus species are dominated there. Yes? Quercus species are dominated.
Yeah.
Yes.
Mainly Quercus species.
Yes.
And there is a good slide for your questions. I will show the.
Yes.
These are dark greens are Quercus distribution on European part.
Quercus.
And the right side you see the other species. And we see the oak ocean.
Yes, I see. What about the forest on the Black Sea coast? Which species dominated there? And what about the
On
Mediterranean?
higher altitudes, more than 500 meters. You know the highest altitude of
Yes.
Yıldız Mountain, Stranca Mountain is the 1,131. After the higher parts of the
On the mountain.
upper than 500 meters, beach, Fagus orientalis,
Yes.
mixing the oak species.
Yes, Fagus
and also lower band is the Carpinus.
Carpinus. Yes, I see. What about the Pinus species? Pinus species.
No pinus.
No pinus.
No naturally pinus
interesting.
species. No natural conifer. One area in the Vize, you know Vize, Kıyıköy, and the botanists discuss this is natural or relic or
With the
it's
human
not natural.
activity.
Pinus nigra.
Pinus nigra, yes, I see. But what about the Mediterranean?
Mediterranean region is the Pinus pinaster,
Pinus.
Calabrian pine, and the upper hills, Cedrus.
Okay,
Cedrus libani.
I see. This distribution of the species, forest species, Strangia Mountain, coast of Black Sea, and the Mediterranean, maybe it's related to the climate and the
Yes.
soil,
Yeah.
contrary. And finally, my question: where is more frequently appears the fires in the forest?
In Turkey,
Yes, in Turkey.
against the world situation, in Turkey, the reason of the forest fire is illegal, not natural causes in Turkey, unfortunately,
Artificial. by
depending on the reports.
human. Okay, thank you.
Also, it is very common in the European part, and last week, there was a fire in the Bulgarian border, and you know Greece very suffered the heavy fires last month.
Thank you for answering and for the question, of course. If you have other questions to the speech? No, thank you again. And now there is some changes related to the third speaker, because according to the information from our organizers, Dr. Mariana Petkova from my country, from Bulgaria, she should come from the Agricultural University Plovdiv, and she is on the way, but unfortunately she didn't reach our place. In this case, our invited speech will be only 2. I apologize for that. I would like once again to say thank you to our 2 speakers. They collect the data, show us the results. The presentations were very well illustrated. Sincere thanks are going to both of you and also to you for the listening. According to the program, in this case, we should go to the lunch for approximately 1 hour, and after that, from 1, we will continue with the first session, where our invited speakers will be actually chair of these sessions. Once again, thank you.
Good afternoon, ladies and gentlemen. We welcome you in the afternoon session after the nice lunch we had. And we are going to hear Professor Larek from Algeria, who is going to talk us about suppressive effect of compost to control dumping over disease of Aleppo 5 seedling in northwestern of Algeria. So we have the first speaker from Algeria in this session, and I had an interesting discussion before I come to this point with some fellows from Algeria who I had a chance to meet in Morocco, in Tunisia years ago. Dear Larek, you have the right, you have the step. Thank you.
Okay, thank you a lot. I am so happy to communicate today, and I will present my communication. It is about the suppressive effects of compost to control dumping of disease of Aleppo pine seedling in northwestern of Algeria. My presentation will be in French language, and if someone is went to explain him in English, it's okay. Okay? Then donc, notre sujet, c'est sur l'effet suppressif du compost. Vous avez les champignons des champignons de fonte semée, donc qui causent des dégâts sur les plantes forestières dans les pépinières. Donc, je dois suivre le plan suivant qui je commence par l'introduction, les objectifs, puis matériel et méthodes, résultats et discussions, et je conclue par la conclusion et perspective. Donc, pour l'introduction, donc les Fusarium rhododendron et le Pythium ultimum, variété ultimum, sont des champignons ubiquitaires telluriques. Les plus pathogènes, ils sont responsables de fonte de semis, donc des cultures, notamment les arbres forestiers. Donc, le large spectre et la grande adaptabilité de ces pathogènes ont suscité un grand intérêt. Donc, en raison de son grand impact économique, il a été classé comme des pathogènes fongiques les plus importants. Donc, durant les dernières années ou ces dernières années, la résistance et l'apparition de la résistance chez les populations de champignons, le coût élevé des fongicides et leur effet néfaste sur la santé et l'environnement, donc nous a permis de chercher des alternatives. Parmi ces alternatives, donc, on a les composts. Donc, l'aptitude suppressive du compost aux maladies des plantes a été attribuée donc, à leur composition chimique et à la disponibilité des éléments nutritifs et à la composition microbienne due aussi bien à l'apport des micro-organismes qu'à stimulation ceux du sol. L'apport de ce produit sur les sols agricoles permet d'entretenir leur statut organique, c'est-à-dire la qualité et la quantité de leur matière organique endogène susceptible de conditionner leurs propriétés physiques, chimiques et biologiques. Donc, le context of this subject is the use of compost exactly to control or to suppress the dumping of disease. Donc, notre objectif, c'est la préparation premièrement du compost avec des variables composantes et puis l'analyse de la qualité physico-chimique et mycologique de différents composts. Et après l'évaluation des effets des extraits de compost in vitro et in vivo et la détermination des métaux lourds par ECP-MS et la purification des composés chimiques et fulviques. Donc, premièrement, on a la préparation du compost. Ces composts ont été préparés par différents mélanges et différents pourcentages avec des incubations qui varient de 6 mois jusqu'à 1 an. Donc, concernant la caractérisation physico-chimique du compost, donc, nous avons réalisé premièrement des extraits ou l'extraction des filtrats de compost qui subit des déterminations du pH aqueux, détermination de la salinité du compost et aussi la détermination de la matière sèche et la matière organique. En ce qui concerne la caractérisation biologique, des analyses biologiques du compost préparé, nous avons poursuivi la méthode décrite par Lapillé, la méthode de suspension-dilution, où nous avons choisi aussi 3 concentrations, 10 puissance moins 2, 3 et 6 sur le milieu de PDA. Donc, d'après les résultats obtenus, nous avons fait une identification et caractérisation morphologique des champignons obtenus. Nous avons aussi calculé la charge fongique. Nous avons calculé la charge fongique et la fréquence d'isolement des espèces apparues. Donc, pour l'effet ou les tests in vitro, nous avons testé l'effet des extraits de compost sur... Premièrement, nous avons préparé des milieux de culture à base des extraits de compost, puis nous avons testé leur capacité ou efficacité sur la croissance mycélienne, la sporulation et la germination, bien sûr, sur 2 milieux, PDA et CMA. Donc, c'est pour ça que nous avons évalué l'inhibition de la croissance mycélienne, l'effet sur l'inhibition des sporulations et aussi la germination. Donc, concernant l'analyse chimique du compost, donc, les 4 composts où l'analyse chimique a été réalisée à l'université ou au laboratoire au service des analyses élémentaires, l'université de l'Espagne. Donc, nous avons bien sûr déterminé les métaux lourds par l'ECP-MS, donc, et en même temps, nous avons fait une évaluation des acides fulviques et humiques. Pour l'effet suppressif du compost par des tests in vivo, normalement, nous avons fait une contamination du sol par les agents pathogènes, le Fusarium rhododendron et Pythium ultimum. Donc, après la contamination du sol, nous avons fait un mélange de sol contaminé et de compost à 50%, puis nous avons fait l'ensemencement des semences. Et après, nous avons fait une évaluation de l'incidence de la maladie par calculer le nombre de plantes infectées par rapport au total des plantes. Donc, l'analyse physico-chimique et biologique du compost préparé. Donc, d'après les caractérisations physiques, ces composts sont bien décomposés. Donc, d'après leur aspect annuleux, d'une couleur foncée et l'absence de l'odeur. Donc, pour l'analyse mycologique, nous avons remarqué que nos composts ont été enrichis par des populations microbiennes ou des champignons. Donc, la présence de ces champignons, dans la plupart du temps, assurait la décomposition des déchets organiques. Donc, on a trouvé, bien sûr, des espèces, différentes espèces, par exemple le Fusarium, l'Aspergillus Penicillium et l'apparition du genre de Trichoderma. Même Rhizopus, Absidia, Mécor et le Cladosporium. Donc, d'après les analyses statistiques, nous avons relevé que la présence de trichoderma dans nos composts, c'est un bon indice dans la protection. L'analyse chimique du compost, donc d'après les teneurs de pH, la salinité et la matière sèche, nos composts sont bien dégradés, donc, et sont bien dégradés. L'effet des extraits des composts sur les agents pathogènes telluriques, donc les tests in vivo, donc approuver la capacité de ces composts d'inhiber la croissance mycélienne avec des pourcentages très élevés, exactement pour le compost numéro 2 et 3, pour les isolats de pythium et fusarium, où l'inhibition atteint jusqu'à 81%. Donc, même pour les pourcentages d'inhibition de la production des spores, nous avons remarqué que ces extraits de compost ou ces composts a un effet inhibiteur très important sur la sporulation et la germination aussi des spores. Donc, nous avons remarqué ici que la germination a été inhibée jusqu'à 88%. Donc, concernant l'analyse chimique des composts, d'après les résultats obtenus, nous avons remarqué que les acides humiques, l'apparition des acides humiques avec des valeurs variées de 0,7 et jusqu'à 3,5%. Donc, ces valeurs s'indiquent la bonne dégradation de la matière organique et aussi s'indique la maturité de nos composts. Donc, l'apparition des acides fulviques qui est une étape élémentaire intermédiaire, c'est une étape intermédiaire de dégradation, d'humification ou d'humification de la matière organique. Donc, elle est liée exactement par le mélange et la durée de compostage et la méthode de compostage. En ce qui concerne les métaux lourds, nous avons remarqué d'après les résultats obtenus que les teneurs sont très faibles. Donc, ça indique que notre préparation de compost ou non-compost ne sont pas toxiques pour les plantes. Donc, d'après le tableau ou les normes d'AFNOR françaises, donc, on peut classer nos composts dans la classe A et on peut utiliser comme dit biofertilisants. Donc, même pour les compositions des illégaux, éléments, nous avons remarqué la présence des éléments nutritifs qui sont bien sûr enrichir le sol, surtout pour le Fe, le zinc, le calcium, etc. Ça s'indique que notre compost joue un rôle comme un biofertilisant. Donc, l'effet suppressif du compost in vivo, donc vous avez les agents pathogènes. D'après l'évaluation, nous avons remarqué que ces composts ont un rôle très important dans l'inhibition de la croissance mycélienne ou sur l'apparition des symptômes de la fente de semis. Donc, une réduction de l'incidence de la maladie qui atteint jusqu'à 47%. Donc, après le traitement, donc, en conclusion et perspective, le compostage est l'une des méthodes les plus efficaces pour protéger nos cultures contre ces maladies. C'est le traitement par excellence qui répond à toutes les conditions dans les limites financières. Au cours de cette étude, nous avons montré que la qualité du compost et son efficacité dans la protection liée au mode et la durée du compostage et la composition du mélange L'étude des propriétés physico-chimiques et biologiques du compost est une étape essentielle pour évaluer sa qualité. Les tests in vitro nous ont permis de tester l'effet inhibiteur des extraits de compost vis-à-vis la croissance mycélienne, la sporulation, la germination des conidis, des agents pathogènes. Donc, l'analyse physico-chimique ont relevé que ces composts possèdent un taux d'acide humique important. De même, la présence des métaux lourds est en faible teneur selon les réglementations mondiales. Donc, de même, les analyses de composition élémentaire des macro-éléments, comme le phosphore, potassium, magnésium, permettent d'utiliser ces composts comme des biofertilisants. Les tests in vivo, c'est l'étape complémentaire afin de confirmer l'effet protecteur de compost contre les pathogènes telluriques. Une réduction très importante de l'incidence de la maladie a été signalée. Ces composts ont prouvé un effet protecteur contre les pathogènes. Du point de vue scientifique, notre travail montre de façon très intéressante que les composts sont considérés comme amendements fertilisants et une alternative biologique pour lutter contre les maladies. En perspective, afin de valoriser ce travail, nous proposons de réaliser une expérience pilote pour la production de différents composts en vue d'aboutir à la conception et à la réalisation d'un guide méthodologique de lutte biologique fiable afin d'enrichir les besoins du sol agricole en plus de valorisation agronomique. Leur effet non seulement sur le sol et les plantes, elles agissent aussi sur la protection de l'environnement afin de minimiser les risques de pollution et d'assurer la bonne production de rendement. Et merci de votre attention. Je suis un peu paniquée.
Thank you, Dr. Fatiha, for your important scientific work. I left you more than the time you needed, but it was interesting. Do we have any question, please? Okay, thank you very much.
Okay.
There is one question.
Hello, I am Dr. Der Khaladi Haj Mustafa of the University of Mascara. Donc, j'ai une question pour ma collègue. Donc, your compost contient Hg, mercure, and plomb.
Yeah.
Donc, ce sont des produits très toxiques.
Oui, on a fait nous avons fait, d'après les normes d'AFNOR françaises, donc nous avons
Hg and plomb.
Yeah. Ok. Donc, dans ce tableau, donc, ça c'est les normes ou la réglementation française. D'après les normes d'AFNOR qui sont publiées, donc la caractérisation de notre compost, c'est classé dans la classe A.
Parce que cette roi, il est à 200 mg par kilogramme.
Oui.
200
oui.
mg par kilogramme. Ici, c'est tri. Plomb. PB. 2900 and Hg.
Non, c'est 120.
Okay. And what is the difference entre C1, C2? La différence?
Non, c'est la différence dans la matière première, la composition.
Composition.
Parce que différentes compositions avec différentes concentrations.
Donc vous n'avez pas donné la composition?
C'est.
Ah, ok.
Donc,
Thank you.
Pardon.
Would you please have more discussion during the
Donc,
break?
Okay.
Okay.
All right, thank you.
Thank you very much. We move to the next speaker, who is, pardon me? There is another one. Okay.
Je continue peut-être avec la question de monsieur. Donc pour le mercure, parce qu'il y a une activité microbienne au niveau du compost, n'est-ce pas? Est-ce qu'il n'y a pas risque de la transformation du mercure cationique peut-être au mercure organique dans le compost, parce que c'est le plus dangereux? Et une autre question par rapport à trichoderma. Vous avez dit que la présence de trichoderma, donc c'est un bon signe. Qu'est-ce que ça veut dire?
C'est un agent de lutte biologique. Donc la présence de trichoderma dans le compost, ça veut dire que on peut bien sûr premièrement prouver la résistance chez la plante, en même temps le contrôle des agents pathogènes au niveau du sol. Donc c'est un agent de lutte biologique. En même temps, c'est un agent.
J'ai une question, bon, je ne sais pas si les micro-organismes qui se trouvent dans le compost, est-ce qu'ils sont capables de transformer le mercure cationique au mercure organique, le CH3?
C'est possible parce qu'il y a aussi des bactéries dans les composts. Ça se peut, ces bactéries peuvent transférer ces agents, ces métaux.
Ok, merci.
Thank you. We move to the next speaker. Would you please use the, yeah, because we pass away, far away. Thank you. We are going to attend an interesting topic. Synthesis of silver and gold nanoparticles from onion peel bio-waste. The speaker is Dr. Kamslet Tan.
Yeah.
Okay. And also the co-author is Neted Sadgin. Is he here? Okay.
Yeah.
Kamslet, you have
Yeah.
the step.
Thank you. Dear colleagues, before starting to my presentation, I would like to thank the organization committee to give me the opportunity to present my work. And I will talking to you today about green synthesis of gold and silver nanoparticles using red and yellow onion peel, also onion skin extract. As is the seen, the overview slide says the titles for each section. First, what's my motivation and aim? Then I will show you introduction and methods. Finally, I will show you our results and conclusion part. The pivotal role of the plants, vegetables and fruits in health is primarily due to their availability of minerals, vitamins, phytochemicals and antioxidants. Thanks to their rich content, they have also a wide range of the applications in complementary and also alternative medicine. For example, onion is one of the foods that we use constantly and also used in many different areas due to the diversity of its chemical compounds and is consumed in almost daily meals, or salads are the crown jewel of the table. But however, when we think about it, these fruits and vegetables that we use leave a lot of waste on the way from the field of the table. And it's known that this is a worldwide problem. In Turkey, approximately 45,000 tons of onion peel waste and 542,000 tons of stale bread are wasted every year. It's known that the total annual kitchen waste also generated only in Ankara, the capital city, is approximately 5.35 megatons. This is really very huge number. And in this sense, the number of these publications also on food waste or agricultural waste has increased significantly in recent years in the Science Citation Index of the Web of Science database. This is also an indication of an increase in academic interest in food waste. Quercetin and other flavonoids in onion waste are of interest due to their bioactive properties and potentially beneficial effects as they can exhibit anti-cancer, anti-obesity, antioxidant, anti-inflammatory activities. That's why nanotechnology is attracting increasing attention also in the recycling of these wastes, especially food and agricultural in recent years. Nanotechnology can also transform biodegradable waste into products for human use. And using the biodegradable waste as a source in the production of nanomaterials can contribute to sustainable waste of nanotechnology or transform these wastes recycling into a value-added product. For this reason, there is currently widespread interest in green synthesis methods with rapid, eco-friendly, and low cost. In the green synthesis of metal or metallic nanoparticles, various biological materials such as bacteria, yeast, fungi, and plant or plant extracts are employed. But many studies have focused on the development of common processes of the synthesis of these metallic nanoparticles using available green technology and biological resources. However, few studies investigated the use of these waste materials in the nanoparticle synthesis. That's why we studied this project, and in our study, unlike the previous studies, we used red and yellow onion peel extract, the mixture, and in the then we used this extract reducing and capping agent for the nanoparticle synthesis. Now for our material part, what did we do? How did we do these extracts and nanoparticles? Red and yellow onion peels were properly cleaned with distilled water. Then after 400 milliliter of distilled water started to boil, 7 grams of red and 7 grams of yellow onion peel was added, and it continued on its for 15 minutes. The temperature was then turned off and allowed to cool at room temperature. Finally, the cooled extract was filtered. For the synthesis, both gold and silver nanoparticles, we used only 5 milliliter of this mixture extract, and then we used 1 millimolar hydrogen tetrachloroaurate for gold nanoparticle synthesis and 1 millimolar silver nitrate for the silver nanoparticle synthesis. All the reaction carried out room temperature. It's well known that the gold nanoparticles exhibit the dark purple color in the aqueous medium depending on their intensity and the size due to their surface plasmon resonance. Here also the color changed yellow to red and then to dark purple color in the gold nanoparticle synthesis. During the formation of the silver nanoparticle synthesis, under this here, the color of the reaction mixture changed from white to pale yellow and then brown. The color changing, the change of the color also confirmed the synthesis of nanoparticles here. Now our results, of course we confirmed, we used various different characterization techniques such as UV visible spectroscopy, Fourier transform infrared spectroscopy, and scanning transmission electron microscopy. Here, as you can see, UV visible spectroscopy results, and the formation of the nanoparticles was confirmed by this first. Surface plasmon resonance spectra were obtained at 229 nanometer for the extracts, at 532 and 431 nanometer for gold and silver nanoparticles, respectively. The zeta average of the nanoparticles determined by dynamic light scattering techniques, the hydrodynamic diameters also as determined from these data, here and here. There is, these data demonstrated that any larger agglomerates can be excluded in the solution. And also the stability of these nanoparticles are really important. That's why we did the zeta potential measurements. A negative zeta potential value of minus 16.1 millivolt and minus 13.5 millivolt indicated the stability of the gold and silver nanoparticles. These negative potential value might be due to the capping agent of biomolecules present in the Peels extract of red and yellow onion. Here, the formation of these nanoparticles also confirmed by scanning transmission electron microscopy, and these images confirmed that the gold nanoparticles were in the nanoscale range here, and but with different shapes, spherical, and here big hexagonal, and also triangular, and slightly rod-like shapes. Silver nanoparticles had a spherical shape, only spherical shape, while gold nanoparticles had various shapes such as spherical, hexagonal, triangular structures. The gold and the silver nanoparticles exhibited different morphologies, although the same extract and the same synthesis route were utilized. Here, the surface morphology and topography of these nanoparticles were examined by field emission scanning electron microscopy, as shown in this figure here. And here, for the chemical compositions. The well-defined gold nanoparticles without any agglomeration in this figure, and according to the EDX quantitative analysis, carbon and oxygen are the main elements. The signal peak of gold confirmed the reduction of the hydrogen tetrachloroaurate to gold nanoparticles. The EDX spectrum of the synthesized silver nanoparticles in this figure clearly exhibited the presence of the elemental carbon and oxygen, again the main peaks, and the presence of elemental silver metal. But the occurrence of other peaks, silicium, might be related with the glass underneath, which held the sample here. And the Fourier transform infrared spectroscopy of extracts and nanoparticles was shown in here, these figures. The region between 3000 and 4000 shows stretching vibrations of oxygen and hydrogen corresponding to the spectral bands of alcohols and phenol groups of these compounds. The peak band in the extract, which was shifted in the case of the nanoparticles. In general, in case of these peaks for the carbonyl group was obtained at 1700. And as shown in this figure, the peak positions in the wave number region, 400 until 1000, were found to have shifted toward a different wave number in the FTIR spectrum of the nanoparticles, which have confirmed the dual function of extract in both reduction and stabilization of the surface of nanoparticles. Therefore, we may conclude that the biogenic gold and silver nanoparticles contain the physicochemical constituents. And our conclusion: in our study, gold and silver nanoparticles were shown to be synthesized with red and yellow onion peel extract characterized by several techniques. In summary, bio-waste onion peel was shown to be a suitable reducing and capping agent for the production of these nanoparticles. And also the potential use of these nanoparticles obtained by recycling bio-waste in various sectors such as the agriculture, food, textiles, biomedical and cosmetic industries not only offer economical benefit, but also avoids the use of harmful chemical synthesis processes and the generation of by-products. Thank you for your attention and listening to me.
Thank you very much, Dr. Tan. Your presentation, very interesting. Thank you very much. Do we have any question? Okay. Next, move to the next speaker. And I would really appreciate. Okay.
Okay. You told, thank you for your presentation, which was very interesting. I like to to ask you about the shape of nanoparticles. You told that you obtained different shapes.
Yes.
Are there a favorite one? Regarding the surfactant effect of some nanoparticle and the interaction with microorganisms, for example. And are there methods to enhance, to favorite one of these shapes or not?
The shapes affect everything.
Yes.
In fact, it depends on the area. For example, if you working in the cell culture, but not plant, in the mammalian cell culture, everybody prefers only spherical shape because the cell also accept only these shapes, and the other shapes not prefer. But if you working plant disease, maybe you want to stop or treating this disease of these plants, then you can also prefer the other shapes because first you can also you can choose the topic and what do you want to do it.
So the shape it depends on
But I prefer
the type
spherical.
of the metal you use, or just as a result of any method you choose.
If you use the chemical process, the synthesis of nanoparticles, or physical process, you can easily spherical or the other shapes. It's not a problem, but for the green synthesis methods, you use the extract, and the extract also includes several flavonoids or the other things. That's why maybe you cannot control the shape.
Okay.
Thank you.
Thank you very much. I would really appreciate if you try to keep your time. It's 15 minutes in order to be on time finally. So, the next speaker is Dr. Demir. Am I right? Oh, no, not exactly. Okay, my friend. So, you're going to talk about a WID?
Yeah, a WID database of Turkey.
Bravo, bravo.
Yeah, and that we created. First of all, it's an honor to be here, and I will make a presentation about a WID database of Turkey. It is first for Turkey, but there is in other countries. And I am from Tekirdağ Namık Kemal University, Department of Biology, by the way. And as we know, WIDs are one of the pests responsible for the yields, quality, and economic losses. And it's estimated 20 and 19% yield losses. And if we want to effective and proper management of weeds, we have to determine risks and identify weeds properly, and we have to take them into inventory, and we have to create checklists of these weeds, and so we can know what we deal with in the future. So also management and the control weeds is important because the functionality and sustainability of the natural environment and biodiversity conservation, food security, and it is important because it prevents economic problems. Also, in world of botany or agriculture, there are lots of databases, and it makes life easier and you can see some of these examples in the screen, and they play important role in many areas today. And also, you know, ChatGPT is really popular, and these are help organizations work more effectively and efficiently by enabling the organization management and processing of big data. So we saw the something is missing in Turkey, and we decided to create a database, but completely based on scientific methods. And finally, we created an open access wheat database, and it is available at this URL. And first of all, we created a UX UI part and front-end side with Bootstrap framework. It is really popular in the web application world. And in the back-end side, we used Python, and for the database, we used PostgreSQL. And for make more faster and more secure request, we preferred REST framework. It is also part of Django framework in Python, and it provides more secure ways to transfer data from user to database. And after we take records or data from providers or contributors, we are making some data corrections. First, our algorithms checking names from other databases like Plants of World Online, GBIF, or Tropicos, and actually it makes some web scraping to take data from there. And after that, our data administrators or experts like botanists or wheat scientists checking this algorithm products, and they are deciding that it is true or not. After that, after data correction, database do image scraping from iNaturalist, and you can reach the all images of that species in this database. And this is our database tables, but it is so small here, and maybe I can. Yeah, the main table is taxon table because all tables connected here. For example, publication, backbone, wheat status, distribution status, is it native, invasive, or naturalized here, and all of tables connected here. So we use biodiversity information standards for our database and store data, and some of them are here, and authors of plant names, we took them all from International Plant Names Index, and other standard is plant names in botanical databases, and we used this, and we didn't create new system, we just take these standards, and every record and every name has a life science identifier in our database. But we are still working on Darwin core system for the communicate with other databases easily. Our databases include taxonomic information about species, the weeds and cultivars, and these taxonomic informations which are hierarchies, synonyms, and other things. And scientific Turkish names, we are using scientific Turkish names like Latin names of species in Turkey. And distribution studies, status, is it native, introduced, naturalized, or invasive? And we can check these things in our database. And images and the basic statistical informations of these wheat species or cultivars. This is our progress, our plans, and we completed just a little bit of our plant data, and still our works are ongoing, and our plan is complete this database in this year. So we have just 8 cultivar plants now, but our plan is make this number 74 in this year, and our other plan is make these records 50,000 in this year. When you go to cultivated plants list, and you will see the cultivated plants like that, and their scientific Turkish names, and some pictures of that. And when you go to cultivar page, and you will see the synonyms, wheat list, taxonomic categories, and distribution status, and references where we took these informations. And this is the example of the wheat list, and you can see the Latin name, scientific Turkish name, family, and how many times this wheat recorded in the literature, and the distribution status, and the references. And these wheats, which they belong, families, genus, or other things, taxonomical categories, and the example of references. And this is the wheat page. If you go to a wheat page, and you're gonna see which cultivars we can see these wheats, and you can see the graphs of that. Also, the gallery is like that, and our algorithm scraping these images from other databases. We completed lots of literature, and we determined some problems or mistakes, and one of them is missing author names of species. And the solution of that, we have to check the species from other databases to find correct author names. And there is an example from a study, Anthemis altissima, and they mentioned that species here, but there isn't author. And when you go to a database, you're gonna see this name took 4 different author names, and which one is that? And we can know that because the main author didn't mention that, because he identified that and he mentioned that he knows the truth, but we don't know. Also, if we try to get, if it is native, it has native distribution in Turkey. Yes, 3 of them have, but 1 of them doesn't has. But we can't decide which one is that. So there is lots of record like that without author name, and we have to write these author names in our studies. Other mistakes is in the literature using synonym names. Also, this example is a synonym name because this name has 4 different author names, and all of them is synonym of a accepted name from 4 different species. Another common mistake in the literature, weak or wrong identifications. And the solution of that, we have to work with experts like botanists, taxonomists, and we have to check herbarium to see variation of specimens or that group we work. Or we have to use this identification case properly in our studies. In other problem is missing herbarium specimens. If we go to this table again, there isn't any binded herbarium specimen here. And if we make a field study, we have to collect plants and identify them. And we have to dry properly and give to a registered herbarium. So then other scientists or botanists can go these herbariums and check these materials. Is our identifications is true or not? And so that's the science actually. If we can't check is it true or not, it is meaningless. So our future goals is here and create a database with morphological descriptions and unique case for weeds. Also AI-powered, artificial intelligence-powered weed management and control methods or suggestions. For example, you will go to database and you will ask, how can I manage these weeds, or how can I control this? And it will give some suggestions to you. And the current and potential distribution maps or modeling potential weeds and projection of the weed risks for the future in the climate change, for example. Thanks for listening me. And
thank you too. It was a really good project.
Yeah.
Do you know how many countries are doing similar work in all over the world?
It wasn't a project, and we just started our laboratory team, and we decided to do that.
Yeah.
And it took like 2 years to complete that.
Okay.
And most of time is the literature searching, and the programming was not too long.
Very good, very good. Thank you very much. Do we have any question? Please.
Hello. Thank you very much for your excellent presentation. My question is, this database, it is only for Turkish plant, or it can be used for plant from other country? Thank you.
It is just for Turkey because it is hard to create a big database for all world, and our another plan is make a big database for all world, but first we need to complete Turkey. As you know, Turkey has a really big biodiversity, and we talk about 11,000 plant species just, and 3,000 endemic plants. And we have to complete this one, and later maybe we can think about the world database of weeds.
Okay, very good. Thank you.
Thank you.
We move to the next speaker, who is
Hello.
Sahar Dahi. Okay. She's going to talk about physicochemical evolution of blueberries during extended frozen storage at -20 degrees Celsius, implications for shelf life and for quality, the most important point, the quality preservation for its product. We have the step. Dear we wait.
Yes. Hello, everyone. My name is Sahar Dahi. I'm a doctoral student at University Mohammed V in Rabat in Morocco. I'm delighted today to be here and present our research, namely physicochemical evolution of blueberries during extended frozen storage at -20 degrees, implications for shelf life and quality preservation. So in order to give a comprehensive understanding of our topic, I have divided my presentation into 4 main sections. First of all, a small introduction, then material and method, results and discussion, and I will finish up with a small conclusion and recommendations. As we all know, blueberries belong to the Ericaceae family, to the genus Vaccinum, which contains approximately 450 species. Known since prehistoric times, the blueberry comes from spontaneous shrub native to the northern region of Europe and the north of America. In the last 10 years, the importance of blueberry increased widely due to their well-known properties, including anti-diabetic, anti-cardiovascular, and anti-cancers, and more other features. However, blueberries is well known as perishable fruits because of their short shelf life and limited production period, which consequently lead to a notable post-harvest losses. So in order to overcome these losses, several post-harvest treatments are necessary, including cold storage, irradiation, etc. In this case, a main question remains: can these treatments preserve the well-known properties of blueberries? So in order to answer to this question, the aim of our study was to evaluate a specific post-harvest treatment, namely the storage of blueberries at -20 degrees for 3 months on their physicochemical and biochemical characteristics. So now let's delve into the details and move on to the material and method section. The plant material we have used originated from Morocco, from a region of Kenitra. In this region, a random sample from the variety Stella Blue were harvested at maturity, then stored at -20 degrees for 3 months. During each month, the phytochemical and biochemical analyses were evaluated. As for the phytochemical assays, we have tested the weight using an electronic scale precision. We have tested the total soluble solid by a refractometer. We have also measured the titratable acidity, and it was calculated according to the following formula. Lastly, we have also evaluated the pH by an electronic pH meter. Regarding the biochemical assays, we have tested the polyphenols, antioxidant activity, anthocyanins, and flavonoids. And before doing that, we have prepared an extra by mixing 5 grams of blueberries with 25 ml of methanol and a drop of hydrochloric acid. This mixture was then homogenized, centrifuged, and then the methanol was evaporated using a rotavapor. Once our extra was prepared, we have evaluated the polyphenol based on the Folencio-Kalte method. After 13 minutes of incubation, the absorbance was read at 750 nanometer, and the results were expressed by milligram of equivalent gallic acid per gram of the sample. Regarding the antioxidant activity, it was conducted based on the PPH method, where we have read the absorbance at 550 nanometer, and the inhibition percentage was calculated according to the following formula. Regarding flavonoids, it was conducted based on the Lamesson and Carnot method. The absorbance was read at 430 nanometer, and the results were expressed by milligram equivalent return per gram of the sample. Lastly, the anthocyanins were conducted based on the differential monomer pH method, where the absorbance was read at 510 nanometer and 700 nanometer. Then the absorbance and the total content of anthocyanins were calculated according to the following equations. Afterward, all results were statistically analyzed using the SPSS software, where we have performed the ANOVA test and the SNK test. Moving on to the results and discussion section, the phytochemical analysis showed that the acidity increased in a non-significant manner during the 2 first months. However, by the end of the storage period, we have noticed a significant increase. This increase was accompanied with a decrease in the pH values, which could be explained by the release of additional acids associated with softening and cell wall degradation. As for the wet, we have also noticed that the wet have a similar trend as pH, and we have noticed a decrease by 21% at the end of the storage period, which could be explained by a reduction in the fruit's water content. Lastly, the total soluble solid show a significant decrease by the first month of the storage period. However, at the end of the storage period, we have noticed a significant decrease by 52%. This could be explained by the loss of soluble compounds in water due to the freezing and unfreezing process. Moving on to the biochemical assays, we have noticed that blueberries stored at -20 degrees for 1 month have a similar level of polyphenol as fresh one. However, after 2 months of course, which could explain that freezing keeps polyphenol well preserved. And after 2 months, we have noticed a significant increase of the polyphenol levels, which could be explained by the fact that cell structure may start to break down, releasing polyphenols. At the end of the storage period, we have noticed that the polyphenol remains stable, and this could be explained by the fact that blueberries have adapted to freezing. As for the antioxidant activity, it exhibits similar trend as polyphenols. The blueberries retained stable during the first month due to protective measures, then it increased at the second month, which could be a response to environmental changes and natural ripening process. At the end of the storage period, we have noticed that the antioxidant activity remains stable, which could be explained by a balance that have been reached between the production and degradation of antioxidants in the fruit. As for the flavonoids, we have noticed that initially, freezing preserves flavonoids, and later the fruit adapts by producing more flavonoids in response to stress, resulting in a significant increase in flavonoids contents. Lastly, the anthocyanins showed a significant increase during the first month, which could be explained by a stress-induced synthesis. Then this level remained stable during the second month due to the fact that blueberry had adapted to freezing, leading to a balance between production and degradation. Even this degradation, the minor fluctuation could still occur, which could explain the significant increase at the end of the storage period. In summary, these compounds' response to freezing stress have vary due to their specific biochemical pathways and functions. Anthocyanins, with their rapid stress response, can show significant increase during the first month, while other compounds stabilize as the fruit adapts to the frozen environment. To conclude, the 3-month frozen storage of blueberries at -20 degrees results in a decrease in pH and Brix, accompanied with an increase in titratable acidity throughout the storage. As for the polyphenols, we have noticed that the antioxidant activity and polyphenols increased after 2 months and remained stable during the 3rd month. However, flavonoids steadily increased from the 2nd month, and anthocyanin content also showed a notable increase after 1 month. Based on these results, we recommended that blueberries stored for more than 2 months should be directed to processing methods to fully utilize their richness in phenolic compounds and avoid issues related to their sour taste and reduced weight. We also recommend further investigation on the impact of different storage temperature like -10 degree or -30 degree or 4 degree on the physicochemical and biochemical characteristics of blueberry over an extended period. We also recommended to explore the specific mechanism underlying the changes in bioactive compounds during frozen storage, as well as the potential health benefits and application of frozen blueberries. That brings us to the end. Thank you for your attention.
Thank you. Thank you, Dr. Sahar.
Yes, Sahar.
Your work, very, very important. You talk about polyphenols, huh?
Sorry?
Polyphenols.
Yes, polyphenols.
Very interesting topic.
Thank you.
Okay. Do we have any question? No? Please.
Thank you. Thank you. Maybe I follow all details. I'm sorry, but I don't understand how can polyphenols or anthocyanin or even antioxidant activity can increase while the blueberries are not on plants. Who synthesize these new molecules? How can increase?
Okay, for the polyphenols or antioxidant activity, it's increased due to a response to a stress. So the freezing is like a stress for them. which could help the cell degradation and then the release of polyphenols and antioxidants activity.
Yes, this can be understood when the plant interact with environment, with insects, with etc., to the stress in general. The plant synthesizes and elaborates new molecules, including polyphenols. But if we have the fruit, I don't understand. I don't believe that we can have new molecules unless maybe the degradation or false indication. I don't know how it is possible.
Okay, polyphenols, it's always present in the fruits. Okay, but because of the freezing, the cell wall degradation, so the polyphenols is releasing. So that's why we have noticed an increase in the polyphenol levels. Welcome.
More discussion in the break. Okay.
Sorry?
If she needs more information,
yes,
the lady,
I will
you can
explain
talk
to her.
during the...
Sure, of course.
Okay, thank you very much.
Welcome.
We move to the next. Please. The next speaker is Emir. My friend Emir, where you come from, it does not appear here. You are from?
I'm come from.
Okay.
I'm a student. I'm third grade.
You are a student?
Yeah.
Very good. Young fellow. He's going to talk about forecasting pesticide used in Turkey with a RIMA model.
In Turkey?
In Turkey.
Yeah.
In Turkey. You said you come from which university?
Namık Kemal University.
Which is? Where is it?
In Tekirdağ.
Okay.
Yeah.
Very good. You have the step, friend.
Thanks. Dear academicians, guests, and participants, before I start, my name is Emir. I'm a student at Tekirdağ Namık Kemal University, I said, in Department of Field Crops, and I'm third grade. The topic of my presentation is to analyze how pesticide usage will change over the next 10 years using a forecasting model. Let's start with the pesticides. Pesticides are substances or mixtures of substances used to prevent, also control or reduce harmful organisms. And there are so many types of pesticides. We can see some of the types of pesticides on the presentation. The most commonly used pesticides are herbicides and insecticides. These are used in buildings, fields, houses, and other similar places. Pesticides have harmed the environment, but they also have benefits. Pesticides can be used all over the world to protect agriculture products from pests, diseases, and weeds. Thus, pesticides can increase harvest efficiency. On the other hand, pesticides residues threaten human life throughout the food chain, and the use of pesticides accumulates in plants in the long term and harms the ecosystem. If you consider benefits and harms, we are curious about trend of data. Will it increase or decrease? In this study, the autoregressive integrated moving average model was used to forecast pesticide use in Turkey for the next 10 years. Stakeholders and government can use that data for action about future or now. Let me talk about why are we prefer to choose ARIMA. Our data is limited and it is not suitable for artificial intelligence algorithms like neural networks and regression models.
ARIMA models can also provide reliable forecasts and confidence intervals as they are based on statistical methods and theory. So this is why we use ARIMA. Our data is non-stationary, and non-stationary data is not suitable for ARIMA. Because of that, we took the first difference of the time series data, and after the first determined the D value of ARIMA as one. After checking the autocorrelation and partial correlation plots, we decided on a P value of 0 and a Q value of 1. The table you see provides the annual average of pesticide usage by year. As you can see, the blue line and red line, blue line means total pesticide use for next 10 years based on FAO and Turkish Statistical Institute data for 41 years. It is estimated that pesticide use will vary between 56 to 68,000 tons in the next 10 years. Based on these reliable statistical data made by ARIMA, the average change over the last 10 years indicates an upward trend of 4.86%. However, this trend is projected to decrease to 2.16% over the next 10 years compared to the previous decade. We also analyzed the correlation between pesticide use, harvest area, yield, product, and temperature change. As you can see, there is a significant negative correlation between harvest area and pesticide use. Therefore, pesticide use is positively and significantly correlated with the yield and production. There is also a positive correlation between the temperature change and pesticide use, but this correlation is weak. The important thing is not just to use pesticides, but to use pesticides consciously. Thank you so much for your attention and time. Thank you so much. Excuse me? Yeah. Thanks. Thank you so much.
Yes, please tell me. Can you just repeat your question, please?
I need to know about the fruit that you used. The taste of the fruits is
Okay.
change or not with the different components that changing? The taste change or no?
Okay. As I said in my presentation, I have tested the phytochemical analysis and the biochemical. So regarding the phytochemical assays, I have tested the acidity and the Brex, I mean the sweetness of the blueberry, and it was decreased. For the acidity, it increased at the end of the storage period, and the Brex, the sweetness, it decreased. That means the test it changed by the end of the storage period, not at the second month of the storage period. It was similar. Any other question?
Should wait for Professor Keselli? Yeah? Yeah, please wait for a few minutes to see if Professor Turkan had finished to attend the final presentation of this session. Well, I think that they were very interesting papers, presentation of this session, and I would like, as a chairman, to thank all the speakers, all the co-authors of the papers which were presented. I'm really glad that because I see new scientists who work in specific areas. It was really interesting, the database, also the use of biomass. Where is that, the speaker who talked about the second one, I think? The synthesis of silver is here at the gold nano properties from onion. Is he here? No, eh? This is not. Anyway, everyone was really good. Really good. So please wait for a few minutes. If it will not come, we can go out for a coffee and then to return back. But it's difficult, I think, eh? Do we have any question about olive oil, actually? A general question we'd like to have? Huh? No. When we presented this morning, which is really my topic, and as I said, it is a great talk nowadays about this product, about the effect of this for our health. So, now I see the last speaker coming. So, We hope that we didn't take you out from your work, eh? It's okay, yeah? Okay. You see, we had missed one speaker, so that's the reason.
Burada mı sunayım? Neyse burada sunayım o zaman. Mikrofonla uğraşmayalım. Thank you, dear Chairman.
Okay, thank
May
you
I
very much.
start?
Yeah, you can start. You have to go on back, eh?
No, no, I don't
Okay.
have to go back.
So
I'm
let
here.
me announce your presentation. The antioxidant activity of milk essential oils in safflower oil. This is by Turkan Heseli.
Yes.
We have a cooperation in the book. I mentioned in the morning. She comes from Athena.
Yes.
And she's doing a work on olive oil, in oil generally. We can hear you. You have the step.
Thank you, Professor Christakis,
Okay, thank
for
you
the
too.
nice introduction. Sorry about this. I was in the other saloon that I was chairing another session, so that's why it took me a little while to come here. Good afternoon, dear all. I will be talking about antioxidant effects of myrtle essential oils on sunflower oil. I thought this subject could be in importance because sunflower oil has a great importance for this area in Turkey. This is one of my MSc students' research projects, so I will try to express her results here. So my talk will include background information on Myrtus communis extracts. I will be talking about the aim of the study, materials and methods. I will be talking about results and conclusion. Okay, when we consider edible oils, the first and important thing that reduces the quality of edible oils is oxidation. So what we try to do, actually, we put all our effort in order to either make this progress on a slower rate and, if possible, stop this occasion. So, because what happens with the lipid oxidation is free radicals formed. So these free radicals will actually initiate the chain reactions, and that will finally reduce the quality of oil. That will also cause an effect on human health. So this is one occasion that we don't want this happen in edible oils. So these free radicals initiate a lot of secondary components, which are known as peroxides and hydroperoxides. And in order to prevent this polyunsaturated fatty acids degradation, we use synthetic antioxidants like butylated hydroxytoluene, propyl gallate, and TBHQ. And TBHQ is not allowed in our country and in some countries as well. So what we're trying to do, instead of using synthetic antioxidants, it's better to go for the natural antioxidants. So there has been a lot of studies on this area in order to find out the effective natural sources instead of using the synthetic antioxidants. So I put something like this to sort of come out here. So what is oxidative velocity happens? It happens in 3 steps: initiation, aggregation, and termination. And if we can add actually antioxidants at the beginning, that will be effective on the effect, that will reduce the effect of either metals or UV light or heat. But once this is effective and once the this means that once it starts, it never stops. So when we come to the propagation stage, these free radicals, once they occur, they immediately forms these proxy peroxy radicals, which is quite dangerous, and this will form hydroperoxides immediately. So I told you that this reduces the quality of oil. The reason for this is this hydroperoxide will break down to the secondary products, which are like ketones, aldehydes, and alcohols. So these components have a flavor, and they are effective on the reducing quality of oil. So therefore, when we add the antioxidants at the beginning, at the initiation reactions, we can actually reduce or slow down the rate. So we can reduce this free radicals formation and, if possible, peroxy radicals formation. Our antioxidants, we sort of like donate their hydrogen in order to stabilize the whole process. So therefore, antioxidants are also known as stabilizers. So, lipid oxidation is important in bulk oils, also important in emulsions like margarine, products like, because on the interface between oil and water phase, our lipid oxidation will take place, and that will again reduce the quality of oil. So we can think of this natural antioxidants can be used in any fats or fat-containing foods in order to reduce their health risks due to the oxidation. So therefore, we can say that our antioxidants are added to emulsion foods such as edible oils, fats, and mayonnaise for these purposes. So there are a lot of natural antioxidant sources to be used as an antioxidants. Today, I will be talking about essential oils. So essential oils apparently prevent oxidation of lipids due to the chain-breaking activity. So we will try to sort of show you how we actually manage this by using the essential oils of myrtle or Myrtus communis. There are some other known essential oil sources like sage, thyme, rosemary, clove, which are rich in phenolic compounds and preservatives. But the myrtle antioxidants activity is being noticed lately. So these essential oils have multiple effects on oils and fats quality. So aim of our study was to evaluate the antioxidant activity of Myrtus communis essential oils in sunflower oil, in water, sunflower oil, and emulsions at different pH. Here we like to show that how the pH was effective on antioxidant activity, and we also tested the antioxidant activity of essential oil of Myrtle communis in frying oils. So there are some other previous studies who showed the activity on that. I sort of tried to put them together, but I'm not going to go into detail. I don't want to bore you too much. I would like to move on to materials and methods. We use sunflower oil, which is obtained from Elita oil factory after deodorization output. Here we like to make sure that oil was free of any antioxidants addition. And we've taken myrtle essential oils from Sigma. We use potatoes used for frying, which is purchased from the local market. So we prepared bulk sunflower oils. We prepared sunflower oil in water emulsions at 30% at different pHs. And bulk oils and emulsions were stored at 60 degrees for 21 days. 60 degrees Celsius is used for shell oven tests. This actually sort of stands for the cooking temperatures. We also use frying sunflower oils, and we use potatoes. We made French fries in these frying oils in order to measure the quality of control and the oils added with myrtle essential oils. And these are our methods. In bulk sunflower oil, we fortified with myrtle essential oils. We measured the oxidative stability. The first sign is peroxide value, and for the secondary oxidation products, TBA value we measured. And we measured total phenol content, antioxidant activity, and we did the same thing for sunflower oil in water emulsions. And for frying oils, we, in addition to oxidation parameters like peroxide value, TBA values, and total phenol and antioxidant activity, we also measured the color of frying oils. So in the end, we evaluate our results by using chemometric analysis. We use principal component analysis. And now our result, I think it's better if I stand here rather than there. So this shows actually our sunflower oil control and sunflower oil with myrtle essential oils added. As you can see, statistical analysis show that there was not much differences between control oil and the myrtle essential oil added. However, what we noticed, peroxide value was slightly reduced in the presence of myrtle essential oil comparing to control. However, this wasn't the case for TBA value. Somehow, the presence of myrtle extracts were behaved as pro-oxidant and increased the TBA value, which is not good. A slight increase we noticed in the antioxidant activity of the control and enriched sunflower oils. So here, from this table, we found significant differences in antioxidant activity, but not much differences between control oil and fortified oil for the other quality parameters. And this is our PCA graph. This actually shows or supports the information that we found for the Duncan analysis. It shows that the antioxidant activity was slightly increased in the presence of myrtle, but it didn't change much phenol content and peroxide value and TBA content. Actually, TBA content was slightly increased. And this is our results for emulsions. What we noticed here, we were wondering whether the pH will affect the antioxidant activity or oxidation parameters. To be honest with you, what we noticed that there was significance in peroxide value and TBA value. However, we didn't find much differences in the antioxidant activity and phenolic content. So, and our PCA graph was supporting this information. What we noticed, however, it can be seen a lot better here. The myrtle extracts essential oils were more effective at either pH 3.4 or pH 5.4. This shows they are effective under acidic conditions rather than basic conditions, which is 7.4. So it works better under acidic conditions. And this is our frying oil results, again, we find significant differences between peroxide value and TBA values, but no differences were found for antioxidant activity and phenolic content. And our PCA value were supporting this information. It was effective in also total polar compounds. Okay, for frying oils, one of the quality parameters is total polar compounds, because when they reach, once they reach 25%, it is quite dangerous in terms of food safety. None of our oils reached 25%, and we found a slight increase in the presence of myrtle essential oils. So it didn't quite work well in the sense of total polar compounds comparing to control oils. The color is another important quality factor, because for frying oils, if the color is darkens, that means that the oil quality is reduced easily. So we measured LAB value and additionally hue value and chroma value. And we found that, okay, this line shows the non-fried oil, and these two lines shows the control and fortified oils. And it was like reducing the color changes or color darkening process to some extent in the presence of myrtle essential oils. And this was again for the yellowness value was a lot lower for in the presence of myrtle essential oils. So this shows that although we didn't achieve much success in the quality parameters, it looks like it's working in the protection of the color. So when I come to the conclusion, I can tell you that due to the negative effect of adding synthetic antioxidants to oils on health, the use of natural antioxidants is preferred. And it has been determined that myrtle essential oil works well under acidic conditions. It has been found that essential oils are effectively preserving the color values of frying oils. And we can suggest that myrtle essential oils can be used in bulk oils, oil and water emulsions lower than 7, and frying oils to improve and functional properties of oil, and to increase the oxidative stability, like reducing peroxide value and limiting the oxidative lipid oxidation to protect oil quality and color properties. So in addition to that, in order to improve the myrtle essential oils on sunflower oil, we can maybe test their effectiveness in like symbiotically, how they work with the presence of other antioxidant sources, or we can work with the other oils as well. So I'd like to thank you for your attention, and I'd like to apologize once more being late. Thank you very much.
Thank you very much, Professor Kesheli. Interesting results, interesting presentation. And I have a question, especially related to the negative results of using this additive.
Mm-hmm. Yes. Yes.
You mentioned that it may have promoting effect.
Yeah.
What was the concentration you used?
Okay, sorry, I forgot to tell you that. We tested at 100 and 200 milligram per kilogram which is the officially allowed level for synthetic antioxidants. So we were trying to make sure that whether they're effective at the same concentration. When it comes to the negative effect, it sometimes happens with antioxidants that they might be, they might have an pro-oxidative effect instead of antioxidative effect that we expected. So it's better to maybe use myrtle essential oils in combination rather than by itself, because its polarity counts on this effectiveness. Its apolar components between apolarity and polarity counts. So it's better to sort of make a sort of combination and test again to get a better effect.
You may try.
Yes.
Because as you mentioned, as you were right, we may have promoting effect, but this happens when we have high concentration. But you mentioned that the concentration was not too high.
Yeah, no, our concentration was 100 and 200,
so
not much.
Very interesting.
Yes.
Thank you very much. And would like to, sorry for taking, for asking first the question, but would like to combine that with my thanks to her. And I would like to ask you if you have any question to ask Professor Castelli. Do we have any question?
If they don't ask, I will ask. Thank you. Thank you, dear Professor.
there are many pests and disease cause yields loss of tomatoes. Root knot nematodes, which are plant parasitic nematodes that feed as endoparasites, also cause serious damage to tomatoes. Meloidogyne are spread all over the world and have a wide host range. The four most important pests worldwide, Meloidogyne javanica, Meloidogyne arenaria, Meloidogyne incognita, and Meloidogyne hapla. Pest management, cultural measures, physical control, biological control, and chemical control methods are used against Meloidogyne nematodes. Unfortunately, chemical control is the most used method for the controlling root knot nematodes. The difficulty of the adaptation of the biological organism to environmental condition, cost of the preparation, the limited use. However, host resistance, which one is the cultural methods, is known as the most effective and environmental friendly method against the root knot nematodes. What is resistance? Resistance, ability to block, eliminate, or reduce attacks by sudden disease and pests. In general, nematode-resistant plant can prevent nematode reproduction compared to non-resistant ones. Resistant to root knot nematodes. Resistant to root knot nematodes was reported the first time in the wild tomato species. This resistant gene, called Me1 gene, was transferred to Solanum esculentum, the cultivar of the tomato, by embryo rescue technique. And especially, there are many genes against the nematodes resistant, Me2 and Me9. Especially the Me1 gene, knowing the characteristic of our genes in their responses to nematodes is important for breeding and control. I will talk about a little bit resistant resources. Tomatoes, like all plants, have several methods for protection and immunity. The plant has an immune system that can recognize pathogen-associated molecular patterns. Triggered immunity, PTI, is first defense line of the response of the plant to pathogens. The extracellular receptor proteins, receptor-like kinases, RLK, and receptor-like protein, RLP, are initiation factors and the activators of the first defense line. The second defense line is triggered by intracellular proteins that contain nucleotide binding sites. To tool-like interleukin receptor, TIR, which is not found in the Me1 gene, and leucine-rich repeats, during the second line defense, there are two modes of the pathogen interaction, direct and indirect. Plant resistance proteins recognize pathogen virulence, we call avirulency, determinants and trigger plant defense mechanism. Then the carefully organized dynamic defense regularly emerge hypersensitive response, and the defense becomes active. In general, a nematode-resistant plant is one that can inhibit the growth of the nematode compared to non-resistant one. The first pathway depends on the gene-for-gene interaction. In this mode, the receptor protein of the tomato directly interacts with the nematode effectors. According to Fuller's theory, the inheritance of both resistance in the tomato and the root knot nematode's ability to cause disease are controlled by pairs of the matching genes. The first gene, like M1, Me1, is the tomato, and the other one is the root knot nematodes. It's called avirulence genes. One of the response of the type of the defense localized programmed cell death. This is one of the most important response of the tomato. This is type of the hypersensitive response after the nematode enters the root to the plants. Nematode avirulency genes produce effectors that trigger the production and the expression of the Me-resistant genes in the incompatible interaction. The second defense mode is not direct gene-for-direct interaction, but an alternative mode called guard hypothesis. In these cases, the virulence factor of nematodes interacts with the tomato accessory protein, resulting in some modification of this accessory protein, which allows for the recognition by plant NBS and LRR proteins that minor for infection. The last result of this indirection in the prevention of the production and growth of the nematodes by the inhibition for formation of the feeding sites. As a result, no giant cells. The nematode avirulency genes trigger the tomato Me1 resistant gene to be active under the salicylic acid pathway, with inhibition by both cytokinin and high temperature. Different approach to strengthening natural resistance in tomato. Marker-assisted selection in breeding programs, genetic engineering in controlling pests, transfer the resistant genes, and resistance effectors. Marker-assisted selection in breeding programs means use of binding pattern-linked molecular DNA markers for indirect selection, the desired plant phenotype. MAS is based on the concept that presence of marker that is tightly linked to gene of interest indicates the presence of that gene. Tomatoes are considered one of the most optimal plants for using molecular markers in commercial breedings. Moreover, molecular markers linked to the Me1 gene have enabled rapid screening of resistance alleles without requiring nematodes inoculation. The use of molecular marker techniques in sync with the new breeding technique is the promising for the advantage of the tomato breedings. Genetic engineering in control root knot nematodes. Although molecular breeding is the method is the most applied, achieve resistance against root knot nematodes in tomato plants. Genetic engineering is future aspiration for the future further increases in resistance, which is, of course, conventional breeding, genetic modification, and genome editing, which is CRISPR-Cas9. Transfer-resistant genes, this strategy is based on two foundations. The first is transfer of the resistant genes from other plants to tomatoes. The second is transfer to the Me-resistant gene from resistant varieties to susceptible one with high production qualities. Several resistant genes from different plants have been successfully transferred to tomatoes. These tomatoes transferred with the new gene reduce disease in the transformed plants. Moreover, cloned Me1 is a good candidate for the transfer for susceptible plants. There are more difficulties in understanding the mechanism of the R genes in other plants or some species of the plants in other family. There have been many contradictions in previous studies in the case of other transformed Solanaceae plants with the Me1 genes. Transgenic tomato plants showed reduced chitin content and retardation in the embryogenesis in nematode eggs. Resistant effectors. Proteinase inhibitors are one of the most promising methods for managing the nematodes. Proteinase inhibitors are protein molecules secreted by pathogens, which inhibit the function of the proteinases. Different types of proteinase have been identified in tomato plants. Thank you for your listening. Any questions?
Thank you very much. Any questions from the audience? I have a question. Sorry.
Sure.
What are the further steps that you plan in your breeding program? Actually, which kind of breeding you are using? Classical breeding or new technologies, new genomic technologies? I want to use this MI-gene.
Yes, conventional breeding and biotechnology, we both use as a company. But for the tomato is our only research interest. We are not practically working for the tomatoes yet in our laboratory.
Sorry to hear this.
But we have a tomato department. They are working with the really molecular associated techniques.
Thank you. So we expect some variety with MI gene and resistant to nematode.
Mm-hmm.
Thank you.
You are welcome.
So the next report is from Ali Ayubet, effect of endemic mycorrhizal inoculation on plant growth and yields in Algeria. You have the floor.
Good morning, everybody. Donc, my communications is about effect of endemic mycorrhizal inoculation of plant grown and fields in Algeria. This is our work focused on contribution to food security through the development of endemic mycorrhizal agent in Algeria in partnership with the International Development Research Center of Canada and the University of Leiden. Mycorrhizas have a lot of beneficial effect when we use it. We can stimulate antioxidant defense system. We can improve osmotic adjustment, modify endogenous hormones, increase photosynthetic efficiency, enhance plant growth. And in the root, we can improve water and nutrient acquisition. And there is all the mechanism used by arborescular mycorrhizae fungi. The following steps were carried out during these 4 years of study. The first is the isolation of spore from rhizosphere of wheat plants. After, we have to do a classification of the spore by phenomorphotype in monoculture, qualification of monoaction and synergetic streams, and experimentation and validation of final formulation with farmers. First, we begin by the isolation of morphotype of endemic mycorrhizal agent in arid soil was conducted in Algeria. The sample was collected from the rhizosphere of soil in Ain Targa, which is located south of city of Biskra. This is in semi-arid area. The aim was to determine the endemic mycorrhizal status of the sample. After the mycorrhizal rate of it comes from that palm tree root in the Biskra region, and here we have the photo of different vesicle, mycelium, and spore of the mycorrhiza. After that, we have to do the extraction and identification of spore. The different spore involves a series of weight saving on the soil, followed by observation of living spore under a stereoscope. The observation extends to the microscope after fixation and splitting of the spore. Donc, the observation, we have a very high mycorrhization rate with a global frequency of 100 and an intensity of 18.4. The observation of the last 3 different morphotypes of mycorrhizal spore working in synergy. And we observed 3 different morphology. And we have a positive impact of the mycorrhization on the head of both palm trees, as well as on depth and field and quality. We begin, in second, after the determination, with production of bioculum based on endemic mycorrhizal agent from Biskra, donc from endemic mycorrhizal agent. The producing of endemic mycorrhizal agent, bioculum, lasts for 6 months. Donc, the stage of production, we have the mycotex, it's a greenhouse. We begin with the starter inoculum, daily culture monitoring, specific treatment and watering of in vivo culture, control of symbiosis development, the preparation of elements for formulation come after 6 months. We can see on the picture, and we have production of 300 kilograms of bioculum in back of 2 kilograms. After this preparation, we have take the inoculum to the farmers. And we have a lot of workshops with different farmers in different bioclimatic states. We have semi-arid bioclima, and we have subhumid and arid. And we have give the inoculum to 300 farmers, which has received the inoculum in the back of 2 kilograms, and we have two production of mycorrhiza. The resultant discussion, the application of the formulated bio-input based on endemic mycorrhizal has had a positive impact on all the experiments conducted across different bioclimatic stages, as evidenced by the significant increase in yields of mycorrhizal culture compared to the control. We have an increase about 15 on potatoes and tomatoes, and 14 on bean, zucchini, and peppers, and garlic, 13. We have 30 farmers followed the project only. We give to 300, but only you can look here the picture. This farmer who works with us with potatoes, here M plus with mycorrhiz, here M1 without mycorrhiz. Here bean with mycorrhiz, it's a lawn, more lawn. And here tomatoes with mycorrhiz, not mycorrhiz, and and sorghum. We have sorghum with compost and sorghum with mycorrhiz and compost. And we see a very big difference. In conclusion, after 4 years of research development, several objectives has been achieved. Development of endemic mycorrhizal strain isolate from the semi-arid area of Biskra and adapted to Algerian agricultural soil. Successful application of endemic mycorrhizal among numerous farmers in arid, semi-arid, and subendemic area. Assessment of the impact of mycorrhization on female farmers and on wives of male farmers. The primary and the ultimate goal of this project is to identify investors able to establish a business plan model and can commercialize the innovation product developed in this research project. Thank you.
Thank you. I'm really impressed with your results because I believe that this is one of the future solutions for the climate changes and decrease of mineral fertilizers. Maybe we'll use more microorganism products in the future. Do you have some questions? I believe the topic is interesting.
Hello, my name is Mariana Petkova. I'm working in the Department of Microbiology in Plovdiv Agriculture University in Plovdiv, Bulgaria. I'm interested it's only a fungi who, fungi grows together with the bacteria that cause proliferation of the roots only, or it's only one species in your research? Because I didn't see identification. My question is, do the fungi need bacteria to cause this proliferation of the roots and this effect, or it's a monoculture?
When we do isolation, we have found three morphotypes of mycorrhiz, three morphotypes, and they live together. Donc it's an endemic from Algeria, and it's a mycorrhiz from soil of Algeria which we extract. No, and what they do after the extraction of the mycorrhiz, we have make
it's a
production,
effect of
and
three
we go to plant after the plant. When we make a plant, when we do plant, we make 20 grams of mycorrhiz with the tomatoes. After we have a very good yield.
Thank you very much.
You're welcome.
What you do not know is that Professor Petkova is working on similar projects with microorganisms in different plants. And she will have a report in the end of our session, so you'll hear something similar. Another question from the audience? I don't see. Thank you. Thank you very much. we have some people who are on their way, so we are going a report for the distribution of the plant specimen collected from Turkey in herbariums outside of Turkey. We will see the plant genetic resources of Turkey used, stored, investigated in other countries. Is Dr. Demir? Am I
Yes.
right? Yeah, you're welcome.
Thank you. Hello, dear academicians and guests. Welcome to my presentation, and I will make a presentation about distribution of the plant specimen collected from Turkey in herbariums outside of Turkey. We call that outside of Turkey because we are still in the early age of digitalization. We don't have proper databases or virtual herbariums in Turkey yet, but some institutions started working about that. That's why we limited our study just about outside of Turkey. And as you know, Turkey has really big biodiversity, and it's located at the convergence of 3 continents. And Turkey occupies just 0.6% of the world's land surface, but is home to 2.6% of the world plant species. The numbers looks like very low, but it is really huge when you see the numbers in the other pages. Also, Turkey is in the cross-section of 3 phytogeographical regions, and that's why we have lots of plant species in Turkey, and that's cause also different climatic areas in Turkey. And if we compare with Europe, Europe has 13 plant species, but only Turkey has 11,000 plant species, and over 3,000 of these are endemic for Turkey. And in the early 18th century, botanists and other scientists started to discover the new world, and they started to collect plants, animals, and other things, but the gathering plant is very important because of it is gene resource for future. And they studied, described, and named them with precision. In this way, many novelties accumulated in the European herbaria. And Tournefort was the first visitor of Turkey for botany, and he collected lots of plants, and he wrote a book about that. But he didn't publish any new species from Turkey, and he just gave them to the Lamarck, and Lamarck published these names of Tournefort. And he visited mostly Aegean Islands and Anatolia. And after that, the first, also one of the important resources, Flora Orientalis, written by Boissier, and in that years also. And because of richness of the biodiversity, Turkey was a really popular country in that time. Then Balans visited Turkey, and he collects almost 3,000 specimens from Turkey, and he just gave them to Paris Herbarium and Geneva Herbarium, and 345 of them is the new species and the type specimens. After that, Sintenis made some expeditions in Turkey, and he collects lots of plant specimens also, and we estimate that there is 10,000 specimens just belongs to Sintenis. And the history has changed when Peter Headland Davis came to Turkey, and he started a new project, and he was the editor of the 11th book of Flora of Turkey. And he made lots of expeditions, and he collects lots of plants with his colleagues. And we can see the colleagues and Turkish botanists and the others here. And herbaria around the world have been traditionally used for taxonomy and systematic studies, as well as essential tools for education in biological science. And they were often established as a part of universities, botanical gardens, museums, and maybe other research institutes. And a herbarium is a collection of dried, preserved plants, and we are drying them with some process, and there is rules about that. And they are mounted on sheet of paper, as you can see in the screen also. And we are catalog and arrange them systematically for study by professionals or amateurs. And well-known, as I talk about Joseph Pitton de Tournefort, the first visitor of Turkey about botany, and was first who used term herbarium, and that we put specimens. And the foundation of the first herbaria is firmly bound to establishment of botanical gardens in Italy in the 16th century. So, as you can see in the map, there is lots of herbarium in the world, and it is about 3,400, and which are an invaluable record of the world's biodiversity about plants. And one of the most significant recent innovations in biodiversity science has been digitalization and online mobilization of specimens, and facilitating the rapid exploration, synthesis, and dissemination of accurate biodiversity data at unprecedented scales. In the old times, we have to go to these herbariums to check these specimens, but now we can just go website and we can see the herbarium specimens, and we can just study them on the internet. And in our study, we just checked virtual herbariums and other databases to find specimens that collect from Turkey. And one of them is GBIF, is an international network and data infrastructure funded by the world's governments and aimed at providing anyone, anywhere, open access to data about all of types of life on Earth. And databases of GBIA, GSTOR, and herbariums with online catalogs were searched based on specimens, as I said, collects from Turkey. And we obtained this data and transferred it to local database of us. And these data were pre-processed, and the names of collectors, the country of collection, family, and genus names were arranged. And incorrect records and also or specimens with low accuracy in location were removed from our database. And when we checked the metadata records of plant diversity in Turkey, and we searched 174 different herbariums, and we detected that there is 2,162 collectors. And this is the summary of our search and databases that we searched before. And we found most herbarium specimens in Royal Botanic Garden, Edinburgh. And it was about 15,000 herbarium specimens because of Peter Hadland Davis. He collected that plants and he just stored them in this herbarium. And the second one is Paris Herbarium, and there is 10,000 herbarium specimens from Turkey. And other one is Wien Herbarium, and there is 7,000, almost 8,000. And the most herbarium specimen belongs to Peter Hadland Davis, and he collected about 20,000 specimens. And according to the results, most plant specimens from the families of Asteraceae, Fabaceae, Poaceae, and the Brassicaceae. Also, most specimens were recorded in the genus Astragalus and Centaurea. So, most important targets of botanical research is an inventory of worldwide and regional floras, and it cannot be achieved without the study of herbarium collections. Therefore, providing access to herbarium collections for the scientific community and wider public is a major current target of all botanical institutions that possess herbarium collections. You have a collection, but nobody can see, and this is meaningless. You have to open it to all world so everybody can see these collections and they can study on that. Herbarium specimens provide valuable data for extinction risk assessment of plants. Also, we know there is a climate change, and we can just determine risks for extinction, and we can see the variation of plants in these herbarium collections. And they constitute a fundamental resource for increasing the number of plant species represented by evidence-based extinction risk assessments. Also, however, most herbariums in Turkey still do not have open access and online databases, and pre-processing and creating detailed list of herbarium specimens in Turkey will contribute greatly to flora revision or checklist studies. I think that's all. Thank you for listening.
Thank you for the report. It was very interesting. Any questions? I'm happy that you understand everything, but I have a question again.
Okay.
I'm really impressed that in Turkey you have so much species, but can you tell me how many of them are cultivated and known for the large audience, and how many are endemic and underestimated and unused?
There is almost 100 plant species. These are cultivated, but not all of them native to Turkey. Some of them introduced from North America, like tomato and other cultivated plants. But if we talk about native plants, and we can say wheat, it is the origin of Turkey, and lentils also, lentil, I mean. And if we talk about the use of people, ethnobotany, and we made lots of ethnobotanical studies in Turkey also to determine which plants are using for that purpose. And we found that it is about 5,000 plants that's used for ethnobotany in Turkey.
That was my second question. So, beside the origin, what other information you can find in the database of varieties? I mean, can you see some characterization or evaluation online in the databases of the other institutions which are and using your species?
We prepared that because, for example, if we make a revision or taxonomical revision study, and it is hard to find collectors' specimens. And for example, in Flora of Turkey, there is only records, but we don't know where is these specimens, and just only collector's name. And when we check that, we can't see where is this specimens or collection of this collector. And we just search these databases to find that. And we will publish this database on an open access platform, Zinado. Maybe you heard that before. We didn't focus on just cultivated plants, and it is all plants collected from Turkey and specimens. How can I say that? This is only for botanical research.
You see that you have to inspire young children and students and fellow researchers to help in this noble research in the future.
Yeah, also there is another project in Turkey, Illustrated Flora of Turkey, and I am the part of that also. I'm author of Genus verbascum and some genus in Poaceae family. This is really big help for us, and it is easy to find, oh, there is a collector, what is name? Davis, and Davis's collections in Edinburgh, Paris, and Geneva. This is good for us because when we go to this herbarium, it will be easy to find them, and because I know there is a collections of that collector. But if I don't know that, I need to go this herbarium and I need to check collections if there is a specimen belongs to that collector.
You know, maybe you know Nordgene in Sweden. It's a consortium of 5 gene banks. Mm-hmm. They have a very nice organization, and maybe it could be useful for you to help your researches and maybe finding friends there and some help, because they are using public resources to finance their ideas, and many people are helping with this enormous database that they have to collect.
Thank you. I will use that also.
Thank you very much.
Can I have one question? Do you look only for the herbarium? Are you interested in some plants that are in wild? For example, for us, plants are sources for valuable microorganisms, and we found out that in Strange Mountain there are endemic leguminous, Cicermumbreti and Vicia incisa, for example, and till 1950 was considered among people who are in science that we don't have a wild leguminous species in Bulgaria, but actually we do. My question is, do you interested also in wild species like this, or you only look at the data in herbarium?
Actually, our focus is on herbariums and botanic gardens collections because we can check them later, and they have some specimens. And we excluded also seed gene banks because these are vouchers, and if they don't have binded herbarium specimens, it is hard to find which species is that, because there is lots of variation in plants also. It depends the geography or other things, and wild species, and we didn't consider that before, and we just focus on herbariums, and I hope it is clear, but if it is not clear, I can...
Thank you. And because these species are in Strange Mountain, which one part is in Bulgaria and 2 parts are in Turkey, probably you also have distribution of these wild species. And
the mountain Stranja.
Yes, Stranja, yes, you know, and they are endemic to this mountain, and I'm sure that you have also from the other side of the border. So maybe it's a good idea to collaborate with university and to enlarge your data also with the wild species, something that is you can find in the forests.
Yeah, I will glad to be part of that. Yeah, thank you.
Thank you.
This project is still running in our university. Thank you very much. You're welcome.
Thank you so much again.
Thank you. We continue more or less in the same area because we are waiting for Zeynep Gül, who will present determination of low temperature resistance in volume perenne genotypes collected from high altitude region. And as I understand, Zeynep is somewhere around, but not in the hall. Can we search for Zeynep? Okay. Then we are going to the next generation of the technology sector with the presentation of IMI analysis for yield performance in maize multi-environment trials grown in Croatia and Turkey. And the lecturer will be Zvonimir Dzunik. The floor is yours.
Dear Chairwoman, dear attendees, thank you for coming to attend the lectures. My name is Zvonimir Dzunik. I'm the CEO of the Public Research Institute, Agricultural Institute Osijek, which is located in the eastern part of Croatia, Hrvatistan, and it's one of the biggest in the Balkan and probably one of the commercially most successful at the region. So the presentation that I'm going to give today and present to you, it refers to how some objective knowledge of, on-hands knowledge of the corn breeders must and have to be approved by scientific methods, especially in statistics, if we want to reach to some inferences that are also manageable and useful for commercial breeding and also for selling certain genotypes at domestic and international markets. So the title is EMI Analysis for Yield Performance in Maize Multi-Environment Trials Grown in Croatia and Turkey. As an institute, we have been working in Turkey for the last 20, even more than 20 years. So this is just part of our investigation and research that we're doing around here, around all Turkey, and from which we extract either inbred lines or F1 plants and commercialize them and monetizing them. So the main purpose of applied scientists such as agriculture and especially plant breeding is to reach the genotypes that are useful for the final users and of course for the market acceptable. So most of plant breeders evaluate performance of genotypes of the certain traits of interest. At this paper, it's for target population and environments of F1 maize hybrids. Statistical analysis, meta-analysis of genotype by environment is interaction, G by E. It is also required to understand how different varieties respond to different environmental conditions. And of course, there's a, as I said, the main objective is to develop, to reach, to create, as you wish, the commercially successful genotypes that will make the farmer's life easier, better, and more successful in terms of growing, in terms of using it, and of course in terms of monetizing them. What are the differences in environmental conditions of this country and a small country such as Croatia? Croatia is 14 times smaller in size of both population and the area. But still have a lot of scientific knowledge, I believe, so we are trying to establish our cooperation in Turkey, even these days, to extend it. As I said, we work with the company called Tarex from Ankara, which also has a breeding station for maize in a small town called Altınova, which is located 130 kilometers northern from the city of Izmir. This is also what we do here and there in Croatia. There are two different types of climate and soil management in this country. Turkey has several climatic zones, of course, including irrigation for all kinds of crops, from vegetables to corn, no matter if it refers to seed production of corn or just for merchandise production. And of course, Croatia, which is located in the Western Balkans, and it has continental temperate regions with only rain-fed conditions, which is less than 2% of the arable land area under irrigation, which is quite low. And the second reason for this investigation was that up to now there wasn't, as far as I know, to my knowledge, comprehensive GBI analysis published in maize grown, at least for these two countries, which has cooperation, as I said, for more than 20 years. So we had two cycles of breeding activities. First, cycle 0, in 2 growing seasons, 2010 and 11, as you can see, Adana, Altınova, both in Croatia and Turkey, Manisa, Karanac, Mersin, and Osijek, with PT means planting time 1, PT2 means planting time 2. So in the second cycle of selection and field trials, we used only locations in this country from the year 2015 to 2019. We called it, we named it Cycle 1. We tried to see if selection in Balkanic conditions, and particularly in Croatia, is good enough for selecting the best genotypes of corn for this country and, of course, for neighborhood countries around Turkey, not around Croatia. So as it turned out, at the end, no. Biologically, it has a meaning, and it makes sense that if you want to develop a certain cultivar, whatever plant species you want to sell or make or create, it is well known from experience to the on-hand maize breeders that inbred lines, I mean, the parental components have to be developed in the area where the F1 generation will be planted mostly. So even though, as I said, it is wide known, still you have to prove it some way in a scientific way. So we tried something. I'll show you. I think we made such a little success of this investigation at the end. So so we took at the cycle 1 only Turkish regions and Turkish corn fields. So the composition of GBI interaction, of course, to additive main effects and multiplicative interaction model, it was based on full orthogonal matrix with 22 hybrids over the 17 environments, as I explained at the cycle 1, and 7 hybrids over 19 environments in cycle 0, sorry, and the 7 hybrids over 19 environments in cycle 1. We also had, of course, missing values, as always, when you work under the sky in the field, and the missing values imputed using an expectation maximization algorithm based on singular value decomposition. Don't ask me how our mathematicians they made it so, but if you want to know, I can put you through them. What is to me, as a CEO, I'm very interested in the final result. And that's what I'm focused on, to show you what we achieved and to see if you agree with it or not. And G by E interaction, partitioned to signal and noise, as always. Noise is something unexplainable, where signal, we tried it based on the analysis of variance given by Gauch and Piep in 2013. That's up-to-date investigation that showed us the most valuable way of how to do it. So let's take the first results that we came across our investigation. G by E decomposition by the additive main effect and multiplicative interaction based on full orthogonal matrix, as I explained, over 17 environments. All kinds of responses were detected in screening, stratified to 4 classes G by E response in ME1. So what we found, we should consider for this presentation 3 main points called age 16, age 21, and age 20. So at the ordinate os and abscissa os, you can find, as shown, the yield on the abscissa os, which is also, we are looking only for the right side of this quadrant, upper right and down right. So left side at the moment is not interested for us, because the yield of every and each of the genotype investigated was lower than the average. And since we work for commercial breeding, we are not interested with genotypes that are below the average, they obtain below the average yield. So age 16, of course, as age 21 and age 20, all 3 of them had the above average yield, positive response for age 16 to improve environmental quality. What does it mean, environmental quality? It's not just the pure quality of the land given by itself, but also mostly, not also, but mostly given by cultivation by the farmer or whoever works and manages that field. The second one, age 21, also, as I said, above average yield, but no or very mild response to changes in environmental quality. And the third one, age 20, above average yield, but best only in specific environments. So the question for the market is, which one we should sell and where? That's the question for the farmers. That's the question for us who try to monetize our innovations, such as hybrids, made of hybrids. But also, it's all, on the first page, I think it's the question for science to give a good answer, and then we in sales and marketing can use it, but exclusively make it on scientific and based on scientific evidence, because if you lie farmers or your business partners, you can do it once and only once and never again. So which one of these hybrids? Let me bring you another slide, which shows what we get it. So now we speak in reality. The first one, P1921, it's a Pioneer maize hybrid with an upper arrow, we pointed with upper arrow, which has above average yield and very positive response to improved environment and quality. We called such a hybrid, such a genotypes, commercial genotypes, a workhorse. That's a workhorse hybrid. That's an American expression, what we were using over there, but also very, very useful for both market and for science. What does it mean, workhorse? That means that that maize hybrid will not disappoint you if you put it in any kind of environment. So you can use it either in below average yielding environment or average yielding environment or above average yielding environment. It will never disappoint you. And let me tell you that this hybrid, P1921 in Turkey, is the mostly widespread maize hybrid in this huge country. This huge country makes planting season on more than 1.5 million hectares of corn, whereas Croatia makes the whole planting season about maximum 300,000 hectares. So it's at least 3 to 4 times bigger size. So that's also one reason why we do not select our hybrids in Croatia, but in Turkey. And the second hybrid, what we developed here, and named him Al-Bayrak, is also above average yield and significant interaction with environment conditions, and we called it racehorse type of hybrid. So what is the difference between workhorse and racehorse? As I explained, what workhorse is, what racehorse is, it's a hybrid to give to the farmers if you well introduced and well known what kind of environment, what kind of manage he's doing with his soil. Is it soil goodly maintained or badly? So if you know a certain area, let's say here it's a case with the Izmir region, not so far away from here, that hybrid will be specifically targeted to a certain area, to a certain farmer's field. And in that conditions, it can obtain more yield than the Pioneers 1921 or any other hybrid. So these two types, when you don't know who you're giving or who you're selling or where you're testing that hybrid, and also when you know it. So it's a different type of hybrid, which is very useful in practical recommendations for planting. So, something to take away from the lectures. Of course, using G/E responses of the certain genotypes. As I explained, there are 2 types of maize hybrid we developed. Workhorse, we also have a workhorse, but not so good as this one, as I showed. That's a scientific truth. And also, we can workhorse type of hybrid, we can address it to static stability. If you read the Becker's from 1981 paper, that's very well explained. Static stability with above average yield performance in this investigation over the assessed environmental scenarios. And on the contrary, hybrid Al-Bayrak, showing significant positive G/E response to increasing environmental quality and could be designated or named as a racehorse. It's a dynamic stability with above average, in this case, yield performance, but best performance in the best environments. And it's not easy to find the best environment and the best farmers in any village, especially now when the prices are all up and go to the sky. So, and instead of conclusion, or also to take away, I'd like to repeat once again that our study, our paper demonstrates the ability to efficiently carry out hybrid breeding, in this case for corn, for very diverse agricultural areas, hot areas, water managed or temperate areas, rain-fed or irrigated areas, etc. And it's based on breeders' experience combined with sufficient genetic diversity and proper G/E analysis, of course. And delineating the G/E responses in hybrid breeding is a worthwhile endeavor in hybrid breeding, especially for high input in agricultural areas like Turkey. By high input, I don't think they use fertilizers or pesticides on excessive level, but I think they manage the soil and they use water as much as they can due to non-rain-fed conditions of growing. And such seasons are very common and almost every season in Turkey. And in context of climate change, this knowledge might have broadening implications because more and more countries turning from rain-fed conditions to irrigations. So I believe such investigations are also very stimulative for other species in agriculture, from vegetables to agricultural crops, to determine very specific in portfolio of certain institute, company, or vendor what seed of what chassis, of what variety to sell to whom, and when you know to whom, you have to know what kind of land that who is having and how it is managed, which is quite difficult. So 2 approaches. One is give him a workhorse hybrid, and the other give him a racehorse hybrid. I think it could be the very same with the vegetable species as well. Thank you for your attention.
Thank you very much. For me, it was a very interesting report.
Thank you.
Do you have any questions? Because I have a lot.
Mm-hmm. Okay.
Okay, I am plant breeder and seed producer, so I understand what you're talking about. Do you have some direct observations from farmers' experience?
Mm-hmm.
I'm selling seeds in Bulgaria.
Okay.
And I know very well what will be the first question of each farmer. No
Mm-hmm.
matter if he knows me or my varieties,
Mm-hmm.
or he's just interested in something new. The first question is always,
Sorry?
can you say what is the first question of each farmer?
For each hybrid, what will I sow, what hybrid, what variety will I sow this year? Will I plant this year?
No, how much I will gain? This is the first question.
It's true.
How much I'll get from this?
Yes, but you know, when you make the gain or lose, it's the end of the season because the prices are fluctuating over the year. The six-month season for corn is quite a long period, and you never know at the end of the day what will be the price of merchandise. You never know, so it's difficult.
And always the responsibility, it belongs to the person who sells seeds.
Yes, of course.
You are the first to blame.
Yes, it's first to blame and to accept the guilty because they will never buy seed again if you blame him.
And we are working for 20 or 50 years
Yes.
ahead, so we have to keep our resume.
Yeah.
So if you have to propose to a farmer
Mm-hmm.
which is new as a client,
Yes.
what you gonna propose? A race horse or workhorse?
If I'm not certain of the farmer, I will propose from my company workhorse.
Do you know what will happen? Do you know what will happen?
No.
My experience.
Mm-hmm. And then I'll tell you my experience for Bulgaria.
So I'm going to a very good farmer
Okay.
with excellent equipment, with a very good rainfall,
Mm-hmm.
deep soil layer, wonderful conditions. So I expect this person to give the best to my seeds.
Yes. Yes.
So I'm offering the very best, the top yield, and I expect records.
Mm-hmm. I agree with you. How many, I mean, there's 1,000 farmers with 10,000 questions always. And let me tell you about my experience with Bulgaria. I also work with a Bulgarian company called Agromaster from Dobrich, close to Varna.
Wonderful region.
Yes, and I also now the institute in Trnava, in Veliko Trnovo.
Get out.
Yes, and I also know quite well the situation with the breeding institutes in Bulgaria from Kneža, and I also met years ago with the Bulgarian academic, he's late at the moment, Tomov, Nikola Tomov, I think. Yes, and we were, at my early age, we were working together. So we still work in Bulgaria. Every year I come to Bulgaria 3, 4, 5 times, it depends, like in Turkey. And Bulgaria is also a country with a huge amount of arable land area that are used for corn breeding, for corn growing. So when our partners, when we get to our buyers, from distributors and farmers through Bulgaria, they always ask, okay, this year what is the best for me to gain the highest profit at the end of the game? That's correct, and I appreciate that. That's also for me as a CEO of the institute. I would like to know at the beginning of every season, at the beginning of selling every seed. It's not only maize we work with. There's also wheat, barley, alfalfa,
and we need
soybean.
the profit.
Yes, and get the profit, of course. Even though we belong to the government, we still finance ourselves in amount of 90%. So 90% is probably at the Balkans the highest percent that every and each agricultural institute finance itself. So that's Osijek Institute in Croatia. I also know the situation in Bulgaria, which is not quite good with the public institute, but I think you have very, very good people and very knowledgeable people regarding both breeding and especially growing corn.
let's hope that farmers will listen to the researchers, not to the sellers, because there are huge difference between marketing
Yes.
and breeding.
Yes, that's why we want to. That's why I wanted to show you the scientific evidence for commercial activities, because you can never lie your buyers, not in Bulgaria, not in the United States, or not in Turkey. Only once you can make that mistake.
One more thing.
Mm-hmm.
Climate change will cause some problems in future, and I expect that one bigger part of our land may be marginal,
Mm-hmm.
which means that those wonderful varieties and hybrids, which are called here race horses, will be produced only on irrigated areas, on irrigated plant fields, which means that maybe we're going to look for this static stability more and more, because we never will know what will be the fertility, the humidity of the soil.
Yes, you're right.
So we have one serious divergence of the plant breeding with stability and productivity in all crops, not only in corn. We're talking
Yes.
about all food crops.
Yeah.
Thank you.
Thank you.
Thank you for the survivors. We have one more plenary report from Mariana Petkova. Professor Petkova will present us a study for endophytic microorganism for plant growth promotion and agrobiotechnological applications. It's on the screen. We had a similar report just a few minutes ago, and here is another aspect of the same research.
Thank you very much for inviting me to AgroBiol conference to present my work on endophytic microorganisms. What is the endophyte? Recently, we are very much focused in biological agents for plant protection. And one of the possibilities is to use endophytic microorganism to protect our plants and to give them more strength to grow faster and bigger. What is an endophyte? Endophyte microorganism colonize plant tissue without causing any damage to the host plant, and they are less likely to be isolated from surface disinfected plant tissue. Endophytes are all over spread in plants. Almost all plants has inside life. They are colonized by microorganisms, and they're fine. The most of endophyte plant relationship are not well understood yet. Adapting when we start our work, we have several procedures from the scientists before, and one of them was Cyber in 2007, and Koch postulate we have these three things in mind. First, endophyte must be associated with the benefit to the host. The endophyte that has been cultured in the medium must produce the same fit benefit when reintroduced in the host again. And the endophyte must be isolated from the experimentally inoculated host. Endophytic microorganisms can be found in virtually every plant studied where they colonize the internal tissue of their host plant and can be ranged from a different relationship, including symbiotic relationship, mutualistic, and commensalistic. Most of the endophytes appear to originate from the rhizosphere or phyllosphere, where some may be transmitted through the seeds. Endophytic microorganisms also can promote the plant growth and yield, and they can act like a biological agent. There is a sixth way for transmission of the endophytic microorganism. Three possibilities are vertically transmission, and three of them horizontally transmission. They are shown with a different color. With a yellow color, this is the vertically way of transmission of the endophyte, which is spread from the roots to the upper plants. You can find the endophyte all over the plant. There is the other possibility with the orange color, that vertically transmitted endophyte remains only in a selected organ or tissue. They have a preference. And the third possibility is endophyte is spread all over the plant, but also can be found in the soil. Horizontally transmitted endophyte can be found also in the seeds. And can be isolated from the offspring. This is the difference between two possibilities, that horizontally transmitted endophyte can become vertically when the seeds are planted for the next year. Sources of endophytes. Endophytes are found within the wide variety of plant tissues, and some observation of the roots. There is a metallurgy, standard metallurgy, and we can detect endophyte in the roots of plants. They are inoculating intracellular species. Beneficial effects which are expected from endophytes are production of phytohormones, auxin, gibberellins, cytokinins, biological nitrogen fixation, mobilization of phosphorus, suppression of stress-related plant by enzyme ACC, which is desaminase activity, induced systematic resistant tolerance against abiotic stress, plant defense mechanism by antagonistic substances releasing like siderophore-ihydrogen-cyanin, and through the competition for colonization site and nutrients. How we can isolate endophyte? Endophyte must be isolated. First of all, we have to surface sterilize the plant tissue, and we get the explant from leaves, stems, and roots, sterilize them, and apply to a culture media in appropriate composition and conditions. And after a few days, we have pure culture and start to analyze for industrial production of some compounds like industrially important enzymes, antimicrobial compounds, compounds that can be used in therapeutics, nanoparticle synthesis, and dyes and pigments. For agriculture use, most of the application of endophytes are plant protection against phytopathogen and insects, release of some enzymes that suppress the growth of other microorganisms or insects, and release of siderophores. Analysis, I will talk a little after a while for siderophores, and analysis we are applying our molecular analysis, biochemical analysis, and antimicrobial activities. To say that one microorganism which was isolated from in one plant can colonize the same species or different species, we have to run some experiment for colonization. Endophytic colonization is when we have seeds or plants. In our experiment, we used 55 days old tobacco plants. And we have two different techniques of colonization, soil drainage and leaf spraying. And we check colonization rate after 7, 14, and 21 day after treatment with yeast endophyte. And the same procedure we use, we cut many explants from leaves, stems, and roots. And you can see on the graph there is almost well colonized, around 60 to 100% colonization of tobacco plants. This result is from entomopathogenic also. This fungi is entomopathogenic, phytopathogenic, and increase the growth of the plants, called Beauveria bassiana, and it's a very broad use in agriculture as a biological agent recently. One of our strain, it's 339. We have a collection of 400 strain. Most of the endophytes that are elucidated in science are coming from the bacteria species, and there are lists of publications with the different bacteria which has endophytic properties as well as this beneficial property of endophytic microorganism. Our work was with bacteria, fungi, and as well yeast. Fungal endophytes are classified to two different types. Clavicipateus endophytes, which have increased plant biomass, confirm drought tolerance, and produce chemicals that are toxic to animals and decrease herbivory. And the second type, which is not very well elucidated, it's class 2, non-Clavicipateus endophytes that comes mostly from Ascomycota fungi. More recently, we start to use in our research yeast as an endophyte. Why yeast? Because yeast has some, first of all, yeast is an integral part of agroecosystems, and they're an attractive option for plant protection because they grow in a very cheap media. They're cheap source as a nutrient, and they don't exhibit any problems or no biosafety concerns when we use like a biological agent, and they don't lead to development of resistance to the pathogens. The novelties in molecular techniques also help us to reconsider our way to examination of isolation of endophytes. And this idea was the new technology that we can sequence the inside microbiota in plants through the next generation sequencing techniques. And in our research, we are using cultivated and wild plants. In this slide, it's a wild plant, Cicer mombreti, which grows endemic to Strange Mountain. But what is interesting in this graph, you can see in A1, almost the red bar represent proteobacteria. Almost, this is two different soils. One is cinnamon forest soil, and A2 is yellow earth podzolic soil. Almost the percent of distribution of all alpha, beta, and gamma proteobacteria is the same. But when it comes to the other group, Actinomycota with the light green and blue, this is bacteria, this is mean all the pathogen, we can see the controversy when actinomycota increase, the pathogenic bacteria decrease. We isolate Pseudomonas fluorescens, Azospirillum, Bacillus species, Erwinia, Bradyrhizobium, Bacillus megatherium, which has a lot of beneficial activities in our further study. Then we used for cultivated maize and wheat plants the same research. We compare soil microbiota to plant microbiota. Because my presentation today was short, I will not giving all the data, but these plantations, this is a result examples for plantation from 8 different farms in Bulgaria, 4 from north part and 4 from south part of Bulgaria. And you can see the distribution of endophytic microorganisms differ in each soil and each region with the typical soil for this region, and of course different cultivation methods. And with the red color in this heat map, it's given the bacteria which is the most abundant and has a reflection on the situation, what is the situation in this land. Is it proper cultivation or not? If it's pathogenic, it is not good. But if it's some with a beneficial microorganism, this is a good picture for us microbiologists. Also the same with the fungal endophytes. You can see the difference in the distribution of endophytic fungi in these plants from 8 different farms. As a result of this study, we established the composition and structure of soil and plant microorganism and factors that influence them to be derived. The next generation sequence analysis help determine the dominant microbial species in the plant and rhizosphere, establish the relationship between the soil microflora and endophytic microflora. And comparative assessment of the influence of geographical location and monitoring of technology on the microbiome of the research plan to be made. And the most important for farmers and for its monitoring for the phytopathogen. For example, in Bulgaria, Rhizoctonia was never a problem like a pathogen on wheat, but prediction happened from 2002 results. This year, farmers who spread and treated with some like if it's a microorganism which suppress Rhizoctonia or chemicals have much more yield and they didn't have a problem. Bioperspective of endophytes. Endophytes as a plant growth promoters, endophytes as a biological agents, again pathogen and pest, and endophytes as a stress controller in plants. Plant growth promoting activities are due to production of some beneficiary substances like indole triacetic acid, which is associated with elongation, division, and differentiation of plant cells and regulation of defense reaction in plants, producing a range of natural products that could be harmless or potential use as a medicine, help plant get nutrition as stabilize phosphorus, and zinc, and some, of course, potential removal of soil contaminants by enhancing phytoremediation, and may play a role in the soil fertility through this nutrition management. Production of indole-triacetic acid. Our experiment shows with tobacco plants that on the 14th day of cultivation, treated plants with this producer of indole was, you can see, the comparison between control and treated plants, much bigger roots and upper leaves. Phosphorus is one of the energy sources that often limits plant growth due to the poor solubility and fixation in soil. Microorganisms that possess enzyme called phytases, they can solubilize inorganic phosphorus and make available for plants to take it. And screening for phosphorus is via special culture, which called Pikovska, and selection of some species that can do this activity. As well as nitrogen fixation. We have 3 types of nitrogen fixation: free-living microorganism like Azotobacter and cyanobacteria, associative, which lives in the rhizosphere of plants and fitting with the polysaccharides from plants. This is Azospirillums and cyanobacteria. And finally, symbiotic fixation with leguminous like Rhizobia and Actinomyces from Frankia. When treated with this one mix of nitrogen, phosphorus, fixation in stabilizers, plants, we have this is experiment with tobacco plants. At the first, we didn't know how many times we experimentally prove that one time it's good enough to be treated with the endophyte. So we treated 2 times and checked what will be the difference, and 2 times after 15 days. But both experiments showed that treated plants has a much bigger, this is like a percent from the control, 300, 100 to 200 to 400, even with the biomass and leaf stem height and root length and leaf length, much higher upper and ground part. Also, some processes in plants were increased by checking a ratio between chlorophyll and carotenoid level. Again, given as a percent from the control, increase of these pigments were almost 300 times bigger. At first week of the treatment, plants sense some stress, but after 1 month, they were giving a much bigger yield. And endophytes as a biocontrol agents, how we can focus to
Excuse me, Mariana. I know that this research is enormous, very interesting, and very long because
I will cut. Yes. I will show you some of this, like a biocontrol, suppressing fungi and bacteria endophytes, production of siderophores, mycocins. This is the small proteins with antibiotic, killing insects. And to kill insects, some agents have to have a proteolytic, lipolytic, and hitinolytic activity, and we can choose the best of microorganism that has most of this activity. And future perspective, development to increase our knowledge, we have to develop some special cultures for endophytic microbes, isolation and identification of more efficient endophytic microbes, detailed study of multiple interaction between endophytes, plants, and pathogen, and appropriate delivery methods need to be developed and transferred to the agriculture use. In conclusion, endophytes are the major benefit of embracing such a beneficial microorganism in the field of agriculture is to bring about reduction of use of agrochemicals to make agriculture more healthy, productive, and sustainable. Thank you very much.
Thank you. It was an interesting research project which continues in our university. Do you have any questions, Mariana? Yes. Can you take one microphone?
First, thank you for your presentation. It's really because we are really interested with the sustainable culture. And I was working for one of the biggest problem for tomato production is Achilops lycoparsis. It's tomato russet mite. And while we are working for the beneficial agents to the tomato russet mites, we understand one of the beneficial mites can trigger the plant defense organism, and plant became resistant to powder mildew somehow, and it was a totally coincidence at the trial. So then we started to, it was a Belgian company when I was working in Belgium, and they started to look after that plant response and plant defense mechanism using the beneficial insects. So those kind of research we are really supporting all the time, and thank you for your effort. We will follow because we are also looking for in our laboratory to use those kind of endophytes in tissue culture because we are not able to use harmful chemicals. So we are trying to optimize media to grow plants and also to trigger the plant response as well. And thank you. We will follow your research.
Thank you very much for your opinion.
Other comments?
Yeah, Beauveria bassiana is really recently very useful for even for nematode treatment. Also, it's some of strain of Beauveria bassiana has also effect on the eggs of not only to the adults, also they can dissolve the chorion of the eggs. So, because of the hitinolytic activity, and very, very useful. Thank you.
It was a very nice conversation here, and I'm really glad that you are still in the room. You see that every one of us is working in different area, but we all have one goal. The climate changes will impose necessity of changes in agronomy, in farmers' thinking, in markets. We have to fight for diversity of the crops, of the products that we produce, and the way we treat our lands and plants. I'm happy to see plant breeders. I'm happy to see people who are still working on plant genetic resources with characterization, evaluation, and conservation of different species. I'm happy to see and to work with microbiologists because we need different methods to fight against pests. And I'm really glad to see you all today. Thank you very much for your patience for your work and for your presentations. It was a pleasure for me. Thank you. If anyone wants to say something, he's welcome. Otherwise, we can continue tomorrow. Okay. Have a nice evening and see you tomorrow. Bye.